Study, na? Study. Yeah, very good evening to all of you. Very good evening. Very good evening to all of you. कैसे हैं सब लोग ठीक है ना? कैसा चल रहा है प्रिपरेशन अच्छा है ना? Yes. Very good evening to all of you. Very good evening. प्रिपरेशन अच्छा चल रहा है ना? सब लोग ठीक है? Yes, please. Very good. And no, at this moment, don't get tensed. Be relaxed. Now, so we will see some of the questions in our production, casting, welding, and forming questions. We will see some of the typical questions which can be, asked in coming gate examination. This same model, same concept type of questions will be coming in gate examination, gate 25. Okay, na? So without wasting much time, friends, can we start this? Can we start the questions? Yes. So first we will start with respect to what? Casting. Right. With respect to casting, we will start. Can you please look at? Yeah. Now the theory questions sometimes, it will be slightly twisting. Right. Can you please look at the question, friends? Look at the question here. Logically, please think and answer the question number 1. Look at it. Which of the following metals having large shrinkage? Please read the question. Gate examination also. Please read the question carefully. Please try to digest the question. एक बार क्वेश्चन को अच्छा समझाने पड़ेगा. Then you think about the answer. Okay ना? In a hurry, we will do small mistakes. So that we want to overcome in gate examination. Accuracy is very important in gate examination, my dear. ठीक है? Right, please observe what is the answer for this. He is not asking about liquid shrinkage, he is not asking about solid shrinkage, he is generally asking shrinkage. Means we need to consider total shrinkage, we have to consider, my dear friends. What we have to consider, my dear? Total shrinkage we have to consider. Total shrinkage is maximum. Nothing is mentioned means total shrinkage, liquid, solidification, solid, pura shrinkage we have to consider. Yes, total shrinkage is maximum for which material? Steel. Pura shrinkage, my dear. If nothing is mentioned here, liquid shrinkage nahi diya, solid shrinkage nahi diya. Total shrinkage, liquid, solidification, solid, pura shrinkage we is talking about. So total shrinkage is maximum for which material? Steel. Total shrinkage is maximum for what? Steel. Next here, for example, if they ask the question solid shrinkage के बारे में, solid shrinkage, if the question is given, solid shrinkage among this one, which is having maximum solid shrinkage, we can think of it here. Solid shrinkage is also having maximum for steel only. Here in this problem, generally solid shrinkage is maximum for what? Lead and zinc we have discussed now. Lead and zinc we have discussed. Solid shrinkage is maximum for. Total shrinkage is steel. Aluminum is having liquid and solidification. Liquid and solidification is maximum for what? Aluminum. This point you can observe. So liquid and solidification is maximum for aluminum. Solid shrinkage is maximum for lead and zinc. Total shrinkage is maximum for what? Steel. Very good. So questions are coming. Which of the material will require large size riser? Riser is compensated by liquid and solidification shrinkage. Okay, liquid and solidification shrinkage is compensated by riser. So maximum liquid shrinkage aluminum. Aluminum will require large volume of riser. Total shrinkage is maximum for steel. Solid shrinkage is maximum for lead and zinc. So pattern size will depend on solid shrinkage. Riser size will depend on liquid and solidification shrinkage. If nothing is mentioned, total shrinkage is maximum for steel material. A is the correct option, my dear friends here. Yes, very good. Liquid and solidification shrinkage is for aluminum. Very good. Now, please think what he has given the question. Whether he is asking about total shrinkage, solid shrinkage or liquid and solid. He is talking about pattern design. He is talking about riser design. Pattern design means this one. Riser design means second one. Okay, na? Right. Very good. Next, this question please observe. Please read the question carefully. Read the question carefully. Which of the following allowances are not required on disposable pattern? Disposable pattern का मतलब क्या है? That can be used only for one casting to be produced. We are using that pattern disposable or expendable. Disposable pattern or expendable pattern का मतलब क्या है? It can be used only once. Upon heating, we are evaporating the pattern. Wax, we are melting, converting into liquid, we are removing in liquid form. So if you are removing the pattern in liquid form, you are removing the pattern in evaporated gases form, it is a disposable pattern or it is expendable pattern. Where we are not removing the pattern in solid form. We are not removing the pattern in which form? Solid form. That's why, which type of allowance are not required here? Draft is not required. Are easy removal of the pattern we require draft na? Easy removal of the pattern draft chahiye. Here we are not removing the pattern in solid form. So draft allowance is not required. Next, machining allowance is to get better surface finish. Wrapping allowance or shake allowance. No, before removing of the pattern ऐसा होता है ना? Wrapping or shaking of the pattern बाद में pattern को निकलता है. ठीक है? So draft and wrapping allowance are not required. Shrinkage allowance we need to provide on the material. ठीक है? So which are they here? A and C both are correct here. A and C both are correct. Please check your answer. Please check your answer. Is asking not required. सब लोग समझ में आता है ना? समझ में आता है ना? Which are not required on the disposable pattern. Disposable pattern means plastics, polystyrene, foam, wax, this type of metals we are using. That can be used only once. We are not removing the pattern in solid form. We are removing in evaporated gases form. That's why draft allowance and wrapping allowance is not required on this pattern. समझ में आता है ना? Check एक बार please check करनिए. Check कर दिए. We have to think. This is disposable means expendable pattern like full molding, investment casting, plaster molding. These things you can consider. Next, this point, friends, you can look at this point. This question. If the coefficient of thermal expansion is this much and the freezing temperature is 1400 degrees centigrade and room temperature is 30 degrees centigrade, then the shrinkage allowance in mm given on the pattern for a critical dimension of 40 mm. Critical dimension of 40 mm. Let us say he has given properties of the material is given to you, my dear friends. Let us say we have, now this is the dimension I am considering. This is the, let us say 40 mm dimension is there for this one. Okay. So if I am cooling the material, we know that there is a chance of shrinkage of the material. Na? If I am cooling from freezing to ambient temperature, it is a solid object. Solid casting is produced already. It is cooled from freezing to ambient temperature. When it is cooled from freezing to ambient temperature, क्या होता है? Shrinkage होता है ना? संकोचन, shrinkage होता है. Due to shrinkage, dimensions are getting what? Reduced. Dimensions are getting what? Reduced. कितना dimension reduce होता है? That we have considered. Delta L will be equal to L alpha delta T. L alpha delta T. L alpha delta T. ठीक है ना? Right. Let's look at here. Delta L is L alpha delta T. Strictly speaking, it is negative because shrinkage means dimension is getting reduced. So how much? This shrinkage of the material that we are going to add over the pattern. That we are going to add over the pattern, that is called shrinkage allowance. So L is the length, it is 40 mm, it has given alpha 2 into 10 power minus 5 per degree centigrade into difference of freezing and ambient temperature. Freezing temperature is how much? 1400 minus 30 degrees centigrade we can consider. So what is the shrinkage? This is the shrinkage of the material. This can be added over the pattern. This can be added over the pattern. 1.096. अरे समझ में आता है ना? Shrinkage of the material. How much shrinkage will be there if you are cooling from freezing temperature to ambient temperature? Delta T is how much? Freezing to ambient temperature. For a pure metal, freezing temperature and melting temperature दोनों same रहेगा. For pure metal, freezing and melting temperature both will be same only. So this is so what is the size of the pattern? Now pattern size, if you want, pattern size is kitna friends? This is 40 plus 1.096. This is the shrinkage we are adding. So pattern size is 41.096 mm. 41.906 mm is the size of the pattern actually. So this is the answer. Answer is this. ठीक है ना? Sometimes they may ask what is the size of the pattern by considering shrinkage allowance. Means this. ठीक है? Yes, very good. Yeah, good. You are on line with these questions. Very good. Yeah, this question please look at. This is with respect to core, friends. With respect to core, C-O-R-E, core. To produce a hollow objects we are using core, na? To produce a hollow objects we are using core. A 100 mm circular hole is to be produced in a casting of length 200 mm. Length is 200, diameter is 50. This is the core, you can observe it here. Okay, core. This is 100 mm diameter, pipe 100 mm, length is 200 mm core. The density of the core metal used is 0.0873 Newton per centimeter cube. Please check the units, very important, Newton per centimeter cube. And density of the molten metal is this much. If the surface area of the core print provided is 10 centimeter square, already is providing 10 centimeter square, but still there is a possibility of unbalanced force is there. That unbalanced force can be supported by using what? Chaplet. He is asking what should be the chaplet area required. That is the surface area of the chaplet. Core print is given. Okay, right. Now please look at, friends, we need to calculate the upward buoyancy force. Net buoyancy force will be equal to, we know that, Vg rho m minus rho c. Please, we have used this particular equation. So this equation can I use when densities are given kg per meter cube or kg per centimeter cube. That is mass density kg per meter cube is given. I have to multiply with what? G. I have to multiply with what? G here. Acceleration due to gravity. But he has given weight density is given to you. Newton per centimeter cube, weight density is given to you. If weight density is given to you, please look at it. Weight density is given, the formula is just simply volume multiplied by rho m minus rho c. Volume multiplied by rho m minus rho c. So this, because densities are given in Newton per centimeter cube. So this is also centimeter cube. So I am getting total newtons will be the final answer. Okay, na? So from here you can calculate, friends, here what is the net buoyancy force P equal to volume pi by 4 d square. Diameter is 10. I am substituting in centimeter, 10 square. And then length is 220. Density differences, please think of 0.0873 minus 0.0441. So from here we need to calculate the buoyancy force. So please check the buoyancy force here, how much you are getting? 67.824. 67.824 newtons you are getting. This is the buoyancy force. Okay. So So stick from this particular one, theoretically we are calculating what should be the core print area required. So what should be the core print area required? We know that P is less than or equal to 3.5 times AC. So AC will be equal to P by 67.824 divided by 3.5. So AC, how much you are getting? Theoretically speaking, from the formula I am getting this finite. Somebody is getting 19.388 kg. Yeah, very good, very good. Core print area is 19.38, very good. 19.38 centimeter square. So this much is required. Theoretically speaking, to support the buoyancy force, this much is the core print area is required. But how much is providing, my dear? He is providing how much? 10 centimeter square only is providing. Actually, how much required? 19.38. But how much is providing? 10 centimeter square only. Means due to less amount of core print area you are providing. Actually, this much is required. But theoretically, how much you are providing? Because of the shape and size, you are not providing 19.38 centimeter square. You are providing 10 centimeter square only. For which there is a unbalanced force is coming. Taken? Which is coming? Unbalanced force. So the unbalanced force can be calculated. Unbalanced force can be calculated. Please write unbalanced force. Unbalanced force, please calculate here. 1 minute. So that is P minus 3.5 times AC. How much this is given? ACT. Theoretically, how much is given? ACT I am writing. P minus 3.5 times ACT. Problem में दिया ना? 10 centimeter square is saying. Surface area of the core print provided is 10 centimeter square is saying. Okay. So please think of from here. From here I can say P is how much? This is 67.824 minus 3.5 into 10 is given. So due to the difference, if you are providing 19.38 here, the unbalanced force is 0. If unbalanced force is 0, there is no need to provide chaplet. If unbalanced force is 0, there is no need to provide what? Chaplet. Because of less amount of core print area, unbalanced force is coming. That unbalanced force can be supported by providing what? Chaplet. So unbalanced force कितना होता है? Unbalanced force is coming, friends, here it is 32.824. 32.824 newtons is the unbalanced force. Look at here, friends. For every 1 Newton of unbalanced force, 1 Newton of unbalanced force, 29 mm square of chaplet area will be required. Chaplet area will be required. For every 1 Newton of unbalanced buoyancy force, 29 mm square of chaplet area will be required. 29 mm square of chaplet area will be required. For every 1 Newton of unbalanced force, 29 mm square chaplet area will be required. So how much this one now? What is the chaplet area required? Chaplet area required will be equal to will be equal to 32.824, right, multiplied by 29 mm square. This is the chaplet area required. For every 1 Newton of unbalanced force, kitna chaplet area is required? 29 mm square. How much is the unbalanced force? 32.84. So the difference we have to consider, friends. So how much you are getting this one? This is 951.896. 951.896 mm square. So he is asking about centimeter square. What is the answer? Please tell me in centimeter square. Chaplet area required is 951.896 mm square. Please tell me in centimeter square. Please tell me in centimeter square. Yes, all of you. So the answer here friends are chaplet area required is 9.5252 centimeter square. Listen here, if you have still doubt, core is supported by providing core prints. If the core print area is not sufficient, then we are going for what? Chaplet. Then we are going for chaplet. So he is providing chaplet here because core print area is not sufficient. Why it is not sufficient? Actually, from this particular formula, how much core print area is required? 19.38 is required. But how much is providing? Practically 10 only is providing. So due to the difference of the core print area is not completely providing because the shape is not sufficient to support that particular area. Okay. So due to the difference of this core print area, there is an unbalanced force is coming P minus 3.5 times AC. If AC in place of this, if you are putting 19.38, how much you are getting friends? It is unbalanced force is 0 hai na? Check. Thoda twisting hota hai problem. So please remember this one. For every 1 Newton of unbalanced force, 29 mm square of chaplet area will be required. That you can remember. How much is the unbalanced force here? 39.824 is the unbalanced force. Unbalanced force is 39.28 is the unbalanced force, for which you can calculate how much will be the force. Okay, please check it. Yeah, 9.51. Very good. 9.51. Very good. Please check it friends here. 9.51 or 9.52 centimeter square is the chaplet area required to support the core. Chaplets are used to support the core in the cavity. We have discussed now. Please check it friends. This question you can check it later. Okay, right. Now this question, please give the answer quickly. Which of the following is of the characteristics of a top gating system? It is top gating, bottom gating system, parting line gating system, step gating system we have discussed now. Right. So in top gating system, velocity zyada hai. Time taken to fill the cavity is less. It is absolutely correct. Time taken to fill the cavity will be less. Used for casting of non-ferrous materials. It is used for what? Ferrous materials. Because velocity is more, the liquid metal is entered the cavity with high velocity, there is a chance of more turbulence and splashing will be there, erosion chances will be there, more chance of oxide formation will be there if it is used for non-ferrous materials. That is why I am not preferring for non-ferrous material. It is used for ferrous materials. It is used for ferrous materials with a small cavity, as a large size cavities can be filled. So there is no turbulence and splashing. Please think of top gating, turbulence and splashing will be there. It will be there. There is a possibility of turbulence. Hone ka chances are there. Favorable temperature gradient of the liquid metal will be there. A and D, very good. A and D, very good, very good. Right, very good. A and D is the correct option. Correct. A and D will be the correct option. Right. Now you can check this question friends. It's a beautiful question friends. Please observe. Can you please use the concept of filling time calculations ke bare mein. A cylindrical casting of 25 centimeters diameter and height. Height and diameter both will be same for a cylindrical cavity. Using bottom gating system. Okay, using bottom gating system. Assuming pouring height of the liquid metal is 25 centimeter. Pouring height of the liquid metal is, if the filling time was 12 seconds for the same cavity by using top gating system. By using top gating system, filling time was 12 seconds. Then area of the bottom gate is, please look at friends, here is a very very good question, अच्छा question है. So pouring height is given friends 25 and this height is also 25 as given. HM equal to HT, anybody get idea here? HM equal to HT, please observe. This is diameter 25. This is height of this mold cavity, that is HM. This is HT, pouring height is equal to 25 centimeter. HM equal to HT, please look at it. If HM equal to HT, what is the condition friends here? Filling time calculations mein. It is filled by using bottom gating system, but the time has given for top gating system 12 seconds is given. So if I consider time taken to fill by using bottom gating system is 2 times of time taken to fill by using top gating system. Can we recollect this particular formula friends condition? If HM equal to HT, height of this mold cavity will be equal to pouring height of the liquid metal. Filling time by using bottom gating is 2 times of top gating system. Okay. So bottom gating system, filling time can consider friends. This is the concept I am going to use. This is the concept we are going to use. Okay. So if you consider for bottom gating system, what is the time friends here? It is a 2 into 12, it will be equal to 24 seconds. 24 seconds. Now here, if you know this one friends, directly we can calculate filling time is equal to 2 times of AM by AG, 1 by root 2G or root of HT minus HT minus HM. Can I use this concept now? This formula, bottom gating formula directly use kar sakta hai. Or we can consider friends here. This from here we can find out area of the gate can be calculated. Area of the gate can be calculated. By using this we can calculate area of the gate. Area of the gate, which gate? Bottom gate area chahiye mere ko. Which gate is required for you? Bottom gate area is required for me. Okay. So filling time is how much? 24 seconds. 2 times of AM, pi by 4 d square, 25 whole square, by AG we have to calculate 1 by root of 2G. Please think of friends, all the units I am substituting in centimeters, so that it is 981 centimeters square. Root of HT, what is root of HT? 25 minus 25 minus 25, 25 minus 25 minus, okay. So from here you tell me what is the area of the gate. Slight twisting there friends. Yes, given top gating time is given. Here HM equal to HT. Time taken to fill bottom gating system is 2 times of top gating system, 24 seconds you are getting. So from here, can I find area of the gate how much? Area of the gate is how much? Please check it. Yes, what is that? .61, very good. 4.61 is the correct answer. Very, very good. 4.61 centimeter square is the correct option, my dear friends. Is the correct option. 4.61 centimeter square is the correct answer. Please look at here. HM equal to HT. HM equal to HT. Please think of here. Mold cavity height 25 centimeter. Pouring height भी same है ना? Concept is important, my dear. Okay? Yes, very good. Very good. 4.61. Very good. ठीक है? Yes, all of you. All of you, please check. Please check. Very good. Very good. Right. So can we make a move? आगे बढ़ता है. All right. You look at here. Please read the question. What has given? What has given? Please read the question. A mould cavity of volume 1000 centimeter cube is filled using a gating ratio 1:1.5:2. 1:1.5:2, my dear. 1:1.5:2. And the height of the molten metal above the gate is 250 mm. Pouring height. Area of the gate is 20 mm square. Time taken to fill the cavity. Please look at it. Whenever, please think of gating ratio is given. Here we are using the concept of what? Choke area. Concept of choke area, because choke area will control the flow of the liquid metal which is entered into the cavity. Choke area will decide the flow of the metal into the cavity, right? It will control the flow of the metal. So we have to calculate the choke area. Choke area will be the gate area. Choke area will be the gate area in case of pressurized unpressurized gating system is considered. So gating ratio is given 1:1.5:2 has given, friends. So it is unpressurized gating system. Choke area kidhar hai? Choke area is at the area of the sprue. It is so this will be equal to what? Your gate area, because it will control the flow of the metal. So we have to consider the choke area in case of gating ratio is given, right? It is an unpressurized gating system. So here I want to find out the choke area or area of the sprue. So for which he has given gate area is given. So area of the gate equal to 20 mm square. So from this particular ratio, what is the choke area? Choke area, this ratio is given now. So choke area will be equal to, area of the sprue will be equal to 10 mm square. 10 mm square. So this concept you can use, friends. If gating ratio is given, choke area we have to consider. Choke area will be the gate area we have to consider. Choke area will be the gate area that you have to consider. Okay? Alright. Now if you consider here filling time, sprue area bottom we are considering. Choke area, area of the sprue as a gate area you are considering. By default it is a top gating system. So assuming top gating system, volume of the cavity by area of the gate root over 2G HT, root over 2G HT. So what is the volume? Check the units, sir. 1000 into 10 power 3, we are converting into mm cube. Area of the gate is 10 mm square, root over 2G 9810 mm per second square, mm per second square. HT is given how much? 250 mm is given. So from here, filling time in seconds, how much? Filling time in seconds, how much you are getting? (45.15 seconds). Exactly. Very good. Yes, good evening, good evening. Some of them are joining now. Very good, very good. Please, please. Good evening. Please check, friends. This concept, please check it. Area, gate area which should not be 20 mm square, because gating ratio is given. If gating ratio is not given, gate area is 20 mm square. There is no doubt. But gating ratio is given. Gating ratio is given. It is unpressurized gating system. Unpressurized gating system. Where is the choke area? Choke area is at the bottom of the sprue. Choke area is at the bottom of the sprue. That will be the gate area here. So choke area will be the gate area here. So as per this ratio, if gate area is given 20 mm square, then what should be the sprue area or choke area? 10 mm square. We have to use 10 mm square. Please check, please check. It is not 22.576. It is 45.154. 45.154 seconds. Please check. It is a 10 mm square, not 20. Choke area will control the flow of the metal into the cavity. It will control the velocity of the metal. Okay. So if gating ratio is given, choke area will be your gate area. Choke area will be your gate area. समझ में आता है ना? ठीक है, ठीक है. Please check, please check. Very good. Please check it friends here. Next question please think of. Now this discussion we are making with respect to pressurized gating system, unpressurized gating system के बारे में we are discussing ना, right. Which of the following is the characteristics of unpressurized gating system? It is MSQ. It is a MSQ question, my dear. It is a MSQ question. Please check it. Now, if you consider it is a MSQ question, it is talking about which type of gating? Pressurized gating system is talking about. Pressurized gating system. Let us say pressurized means 1:2 It is pressurized gating system means 3:2:1. Example, where is the minimum area? At the gate. Minimum area or choke area will be at the gate. Less turbulence to metal flow, more turbulence will be there. Because liquid metal is entered into the cavity with high velocity into the cavity. Because minimum area at the gate na, directly from this choke area, liquid metal is entered into the cavity. Velocity ज़्यादा है. Less turbulence to metal flow is गलत आंसर है. Useful for casting of drossy alloys. Drossy alloys is the correct. Drossy alloys means aluminium magnesium alloys. Aluminium magnesium alloys are also known as drossy alloys. Dross formation will be there. Aluminium oxide formation होता है ना. This aluminium oxide will be formed. This is called dross. Where if metal oxide density will be more than the density of the base material, metal oxide density will be more than the density of the base metal, those are called drossy alloys. So aluminium magnesium alloys oxide formation बहुत ज़्यादा है. इसके लिए right we required less velocity or more velocity, sorry, you required less velocity or more velocity, less velocity will be required. That's why useful for casting of drossy alloys. No, unpressurized gating system is used for drossy alloys. Unpressurized gating system is used for drossy alloys. Pressurized gating system is used for ferrous materials. It will be used for ferrous metal. Second statement is also galat statement here. Gating ratio can be 1:4:4. It is correct. It is also wrong, I think friends. Oh, sorry. Right. This we can think of friends here. It is also wrong. It is gating ratio can be 1:4:4. Casting yield is more. D is the correct option. अरे B कैसा होता है? Useful for casting of drossy alloys? No, I'm sorry friends, B is not correct. Pressurized gating system is used for ferrous materials. अरे velocity ज़्यादा होता है ना, so oxide to reduce the oxide formation it is used for ferrous materials. B, second statement is also wrong. I'm sorry. Actually, only one statement is correct. That is, casting yield is more. When compared to unpressurized gating system, pressurized gating system, casting yield is more. Less turbulence to turbulence, velocity is more, turbulence is more. Useful for casting of ferrous materials. Gating ratio ulta diya na, casting yield is more. Yes, yes, yes. Is asking about, oh shit. Oh right. It is asking about non-ferrous. I'm sorry friends. Pura galat hai. I am talking about pressurized gating system. Correct. So just I will check it here. Right. I'm sorry. Right. I will check it. Please think of. Right. Correct. Pura. I think it is. Yeah. Yes, please. Right, please look at here. Yeah, very good. It is a non-pressurized gating system is given. And that non I have not said. Right. Less turbulence to metal flow, correct. Very good. First one is correct. Less turbulence to metal flow. Used for casting of dross alloys, correct. Gating ratio can be, please think of friends here. 1:4 is, please think of. Casting yield is more. Yes. So it is A, B, C. A, B, C is correct. I'm sorry, I have not seen this non here. Missed it. I have talked, right? It is a non-pressurized gating system, na? Correct. A, B, C are correct. A, B, C are correct. And B is also correct. Used for casting. Drossy alloys means aluminium magnesium alloys. Drossy alloys means aluminium magnesium alloys. Drossy means aluminum, more oxide formation will be there, na? Right. Gating ratio is 1:4:4, correct. Casting yield is more, no, it is more for pressurized gating system. A, B, C, these three options are correct. Sir, right, I am sorry friends, it is a, he has mentioned non-pressurized, I have not seen that, right, I am talking about, yeah, in the question he is talking about non-pressurized gating system. Non-pressurized gating system, velocity will be less, turbulence will be less, okay. So, less turbulence to metal flow is correct, useful for casting of drossy alloys is correct. Drossy alloys means we are discussing now aluminium magnesium alloys. Gating ratio is 1:4:4, correct. Casting yield is less. So, what is the answer? A, B, C. Very good. Yeah. Krishnakanta. Everybody, please, right. Pura. It is unpressurized gating system. This is unpressurized gating system. That I have not seen properly. Okay, right. I am talking of pressurized. Now, it is a unpressurized or non-pressurized gating system. ABC is correct. ABC is correct. Yes, correct. Yes, very good. All of you, please think. Yeah, what I have been listening is a pressurized, right? It is clear? Right. Yeah, please think of it. This question is a good question. In a sand casting process, keeping the surface area constant. We have solved most of our problems where we are putting volume is constant. In our class or please in general discussion also, in the problems we have discussed volume is remains constant. In solidification time calculations, we have assumed volume will remains constant. But for example, in other case, let us say think otherwise. No, different, if you want to twist the problem, I will assume surface area is constant. Surface area is constant, he is talking about, my dear. If the volume of the casting is doubled, solidification time is increased by a factor of how much solidification time will be increased. Okay, na? So, according to Chavino's principle, solidification time is directly proportional to volume to surface area whole square. So, I am considering friends two cases here, TS1 first one, TS2 second one. He is saying that V1 by A1 whole square, V2 by A2 whole square. So, here which are constant friends here? He is assuming surface area is constant. Surface area is constant. So, this is V1 by V2 whole square. Volumes he is saying V1 by V2. He is saying what? If the volume of the casting is doubled, second case V2 will be equal to 2 times of V1. This volume is doubled, na? V2 equal to 2 times of V1. So, V2 V1 by 2 times of V1 whole square. So, V1 will be getting cancelled, it is 1 by 4. 1 by 4. So, TS1 right. TS1, how many times it has increased? Solidification time is increased by a factor of how much? How many times it has increased he is asking. So, TS2 will be equal to 4 times of TS1. It is increased by how many times? 4 times. How many times, my dear? Very good. Very good. Answer is 4, correct. Very good. Very good. Answer is 4, very good. Yes. Numericals, you are very good, strong. Yes, do it. Gate examination success yours. There is nobody can stop you. Proceed. Yes. Two castings are different weight by a factor of 8, but they are both cubes made up of same material. The lighter casting solidifies in 5 minutes. How much time will take to solidify larger casting? Larger means weight is more. So, he is taking friends weight means I will write weight. Different weight W2 by W1 will be equal to 8. Castings are different weight by a factor of 8. So, second one is How many times of first one? 8 times of first one. It is a differ by a weight. Please think of this one. So weight means the same metal is saying that. So we can say volume V2 rho density will be same now. So if density, right, V1 densities, if we cancel friends here, right. So it is a cubical casting. I can say volume is A2 cube by A1 cube will be equal to 8. A2 by A1 will be equal to 2. A2 by A1 will be equal to 2. So what we can say from here? A2 will be equal to 2 times of A1. Then solidification time Ts1 by Ts2 will be equal to volume to surface area first cubical cast, volume to surface area second cubical cast. It is A1 by 6 whole square. Please check it. A2 by 6 whole square. Are cube kitna? Please think of here. Cube means how many surface areas are there? 6 na. So volume is A cube. Surface area is 6A square. Okay. So please think of volume to surface area is A by 6 for a cube. So if you simplify this one, it is A1 by A2 whole square. So this is how much friends? First one is 5 na? Lighter casting 5. Right. Ts2 is how much? It will be equal to A1 by 2 times of A1 square. Don't miss this square. So 2s2 is how much? 20 minutes hai na? 20 minutes is the correct answer. Oh, good, good. 20 minutes will be the correct answer. Right. Next question. A cylindrical top riser. Please read the question carefully. Cylindrical top riser is taken, friends. Top riser H equal to D by 2. Optimum condition is directly given. There is no confusion at all. Is used to feed a casting of a 25, 15, 5 centimeter cube. If freezing ratio is 1.5, then diameter of the riser is how much? Freezing ratio. Keynes method we are discussing now. Freezing ratio. Freezing ratio. मतलब क्या है? Surface area to the volume of casting. Surface area to the volume of riser. Or this can be also written as volume to surface area of the riser. Volume to surface area of the casting. ठीक है ना? Both please look at it, sir. Sometimes to confuse you, they will be giving ratios like this. Please, both are correct here. Both are correct. Freezing ratio is given how much, friends? Freezing ratio is 1.5. Volume to surface area of the riser. What type of riser? Top riser. Top riser H equal to D by 2. Top riser H equal to D by 2. Volume is pi by 4 D square H by 2 times of pi by 4 D square. I am writing second equation. Pi D H. There is no square here, and here it is here there is no 2. It is a top riser now. Top riser, there is no 2, my dear friends, because from the bottom surface of the riser there is no heat transfer. It is pi by 4 D square plus pi D H by volume to surface area of the casting 25, 15, 5. 2 times of 25 into 15 plus 15 into 5 plus 5 into 25. Okay. Now in this particular concept, friends, here I am substituting H equal to D by 2. If I substitute H equal to D by 2 here, you are getting it is D by 6, if I am correct. D by 6. Then we need to find out what should be the D value here. What should be the D value here? sorry, this you are, it may be confused here. What is the D value? Cylindrical top riser is used to feed a casting. Very good. 14.67. Very good. 14.67 centimeter. Freezing ratio, Keynes method का concept है इधर. This is a Keynes method का concept. ठीक है ना? Keynes methods concept. Oh, you are getting 12.25. No, please check it. It is 14.67. 14.67. This value, friends, pi by 4 d square h volume to surface area you are getting is d by 6. This is you are getting d by 6 because you are substituting h equal to d by 2 na. Are optimum condition gaya h equal to d by 2. If you substitute in this equation you are getting d by 6. D by 6. So answer is 14.67. 14.67 is correct. 14.67 is exactly correct. Very good. So direct a simple question for us. So direct a simple question only. Yeah. This question please look at here. Small twist. A cylindrical side riser h equal to d by 2 must be designed to produce a slab casting of dimensions. It was observed that casting has a solidification time of 2 minutes. The diameter of the riser in centimeter such that solidification time is 4. Generally solidification time of the riser ज़्यादा है ना, is 4 minutes. Casting का solidification time कितना है? 2 minutes as given. Then we need to calculate the dimensions of the riser. But here, please see, he has mentioned side riser, but condition given is h equal to d by 2. Means indirectly it is not a optimum side riser. Optimum side riser, what is the condition, friends? H equal to d na. So it is not a optimum side riser. Please remember this point. It is not a optimum side riser because he has given h equal to d by 2 condition he has given. Optimum side riser means h equal to d. So it is not a optimum side riser. Please look at this point. So if you consider, friends, solidification time of casting to the solidification time of a riser will be equal to volume to surface area for casting, volume to surface area whole square for a riser. Okay na? So yes, volumes are not constant, surface area is not constant, nothing is given here. So you have to substitute the values, right? So volume is 7.5 into 12.5 into 2 by 2 times of 7.5 into 12.5. It is whole square by volume to surface area of which one? Side riser, please observe. It's a side riser, pi by 4 d square multiplied by height by 2 times of pi by 4 d square plus pi d h. And here you have to substitute here in this equation h equal to d by 2. What you have to substitute, my dear, here? In this equation you have to substitute h equal to d by 2, you have to substitute. What is the condition? H equal to d by 2. So if you are substituting h equal to d by 2 here, you are getting, you think it is a d by 8, please check it. Solidification time of the casting is 2 minutes. Solidification time of the riser is 4 minutes. Volume to surface area of the casting whole square is also whole square. .49, right? This is 0.49 and this is d by 8 whole square. It's not d by 6, friends. this you are getting d by 8, because here we are substituting, what we are substituting here, h equal to d by 2. In this, in place of h you can substitute d by 2, so that you are getting d by 8, d by 8. So from here you have to calculate what should be the value of d, what should be the value of diameter. No. H equal to D is not given mistakenly. Yes, given correctly. Problem. It is not a optimum side riser. It is not a optimum side riser. Please remember this point. It is not a optimum side riser. Yes, given it is not a optimum side riser. H equal D is given optimum side riser. It is not optimum side riser. We can use any condition, H equal to D by 2 or H equal to D by 3 also we can use, because it is not a optimum side riser. It is not a optimum side riser. Option. Answer is 7.93 centimeter. 7.93 centimeter. Correct. Correct answer. Very good. 7.93 centimeters. If you are substituting H equal to D here, you will get D by 6. You are substituting H equal to D by 2 here, you are getting D by 8. D by 8. Very good. 7.93 is the correct option. Here please, 2 we have to substitute here. Side riser na? Side riser means top surface, bottom surface of the riser, heat transfer will be there. Okay? Please read the question. You have to read the questions carefully. You have to read the questions carefully. That's very, very important. Clear now? Yeah. This question you can think of, friends. It's a simple question only. A true centrifugal casting operation is performed horizontally to produce a copper tube. The tube has an outer diameter of 280 mm and wall thickness of 15 mm. If the rotational speed of the tube is 700 rpm, determine G factor. It's asking about what, friends? G factor. G factor. G factor is asking. G factor. So what is the G factor? We know already. G factor means gravity factor. G factor means gravity factor. It is a ratio between centrifugal force to gravity force. It is a ratio between centrifugal force to gravity force. Please look at here. Please listen here carefully, my dear. In centrifugal force calculation, centrifugal force is mr omega square. Mr omega square. We have to consider outside diameter of the casting. Centrifugal force कहाँ पे act होता है? Look at here. This is a, please think of a die. So die, please think of, we are producing mold or die. So inside diameter of this particular die will be equal to outside diameter of the casting. Inside diameter of the die will be equal to outside diameter of what? Casting. So if I fill the liquid metal due to centrifugal force, it is acting on this particular surface. So it is acting at inside diameter of the die. So that is also equal to outside diameter of the casting. So centrifugal force calculation, always you have to consider outside diameter of the casting or inside diameter of the die or mold. Inside diameter of the die or mold, or it will be outside diameter of the casting. So it is mr omega square, capital R we have to consider. Outside diameter or outside radius we have to consider. So this will be, Fg means m into g, we can say m will be getting cancelled. So you can consider here, friends, In place of you consider R means I will consider D by 2G. R equal to D by 2, I am considering friends omega 2 pi n by 60 whole square. 2 pi n by 60 whole square. So you can think of it here. D value has given 280 mm. 280 mm. So you can substitute in 8 mm. This is 2. G value also you can substitute in mm. This units will be getting cancelled, no? 280 mm. This all G value also, that is 9810 mm per second square. So this is 2 pi n 700 by 60 whole square. So concept please remember, which diameter you have to consider, outside diameter, inside diameter. Outside diameter of the casting, inside diameter of the die. What should be the G factor? 76 point, very good, 76.68. It's a ratio friends, it is a ratio, there is no units. G factor means gravity factor, it's a ratio between centrifugal force to gravity force. If G factor is given, we can calculate rotational speed. Rotational speed is given, G factor can be calculated. Okay, समझ में आता है ना? Yeah, if you are diameter D by 2, I am writing na. Yeah, this you can think of as. Theory questions के लिए एक बार अच्छा, you read the concept because a lot of concept is required. You have to answer this, especially MSQ type of questions, right? You have to know the theory questions completely, and you have to read the question once and twice, and you have to answer the questions carefully. Okay, na? Which of the following statements are false? These are false. False statements are what? Here, look at here. Centrifugal casting is used to produce hollow objects without using the core. It is a same answer, na? Exactly. Centrifugal casting basic purpose is to produce hollow castings without using the core. Correct. Ferrous materials can be cast by die casting. Die casting is meant for non-ferrous materials. Hot chamber or cold chamber both will be used for non-ferrous materials only. Because ferrous materials melting temperature is more. If you are going for ferrous materials, your die should be still made up of high melting point materials like ceramic. Producing of the die by using ceramic metal is difficult. It is difficult to produce a ceramic material die. That's why this statement is galat. Ferrous metals can be used to cast by die. Die casting is meant for low melting materials only. Investment casting is used for high melting materials. It's very good. High melting materials, right? High strength materials like titanium, nickel based alloys can be produced by investment casting. In plaster molding, plaster of Paris, sorry, it is Paris. Plaster of Paris can be used as a molding material. Plaster of Paris, it is also called what? Gypsum. Plaster of Paris or gypsum, POP. Plaster of Paris, no, POP. Plaster molding, molding metal is gypsum, and pattern metal is plastics only. We can consider. It's just similar to full molding technique only. So A, C, D is the correct option. A, C, D is the correct option. Very good. Yeah. So this actually our friend is asking. G factor range is asking our friend. G factor range is around 60 to 80. Our friend is asking what is the G factor range? Range of gravity factor. G factor gravity factor range will be around 60 to 80. It will be around 60 to 80. G factor range is 60 to 80. Correct, na? So A, C, D will be the correct option here. Ferrous metals we are not producing in die casting technique. It is used for non-ferrous, low melting metals only we are using generally. Okay? Right. Can you please look at this? Which of the following casting method uses resin coated sand for making strong and porous molds. Can you please give the answer, friends, this one? P.U. Sharma, what is investment casting? Investment casting means wax pattern can be used, na? Wax pattern, right? Wax pattern garam karo, isko convert them into liquid form, liquid nikalo, then liquid metal is filled into this ceramic shell. Okay, like. Right, friends. Please, I am sorry. Actually, he has given what? Arey, isme kya ji? False statement is asking, na? False statement is asking, yaar. Arey yaar, kya ho ji? He is asking false statement, right. False statement is asking, is not asking true statement here. Please, right. Kya ho ji aaj? Right. Is asking to, what is the false statement here? False statement is what? False statements, ferrous materials can be used in die casting. This is the false statement. Remaining are true, na? Remaining are true. Is asking false, na? Right. Arey yaar. Is asking false statement. It's not true statement. False statement is asking. Right, good. So that is the, so false statement is option B is correct. False statement is asking. Yeah, right, good. Yeah, please. False statement is asking, my dear friends. B is correct. Right. Yeah, this one, please tell me. I think somebody is saying. So in resin coated molding sand means it is a shell molding. Resin coated means it is a shell molding. Shell molding, we are using phenolic resins mixed with the sand. Upon heating, this resin binders are getting activated. They will be sticking over the pattern in the form of what? Shell. So resin coated sand will be there in case of shell molding. Shell molding technique is the correct answer for this. Very good. Yeah, very good. A is the correct option. But sir, can you please look at, actually you have to read theory questions, you have to read carefully. Whether it is asking false statement, true statements, right, which is asking, that's very important. Okay, na? Please read the questions carefully. In this, it is a shell molding we can consider. Right. Now please look at, this type of questions are common in GATE examination. Manufacturing, we are expecting match the following type of questions. Sometimes questions are coming in casting, sometimes pura manufacturing, casting, welding, forming. Now, three topics put together, the questions can be given in the form of match the following. List 1 technique, list 2 the material or a product, which type of products can be produced. Okay, na? So here, shell molding. Shell molding is a semi-precise casting technique. Which is a precise casting technique. Investment casting is a precise casting technique. Slush casting is used to produce a thin and hollow thin castings. Squeeze casting, casting and liquid solidification, liquid forging, casting and forging combination we can consider as a squeeze casting. Plaster molding is used for non-ferrous materials. Just now we have discussed plaster molding. POP will be used as a molding material. It is having low refractiveness. It is used for low melting material. So it is meant for non-ferrous materials only. Plaster molding is this one. So A4, right, B3, A3, B4, C, C2, D, plaster molding is 1. 3, 4, 2, 1, correct? 3, 4, 2, 1, correct, na? Please check it. Yes, please. Yeah, please look at this, is correct, na? Now this one you can see, friends. Casting defects and list type of defect, friends, here. Which type of defect is coming? Yeah, please think of this question, friends, here. Blowholes. Blowhole is a gas defect, friends, here. Blowhole is a gas defect. Cuts and washes. Cuts and washes are due to improper ramming. If the erosion of the sand is taking place, it can be happened. Cuts and washes. Washes means we can say it is a molding material defect. Misrun, it is a pouring metal defect. Hot tears, it's a cracks metallurgical defect. Metallurgical defect. So A3, B2, C1, D4. 3214 is the correct option. 3214 is the correct option. Very good. 3214 will be the correct option. Yeah. So we'll move to this next topic, friends, that is welding. Please look at here. Please answer this question. Welding. Right. Please look at it. Which of the following is a homogeneous welding technique? Heterogeneous, homogeneous, autogeneous. Autogeneous means solid state. Homogeneous means liquid state. Heterogeneous means solid or liquid state welding. Now the question is, which of the following is a homogeneous welding technique? Homogeneous means it is a liquid state welding. Homogeneous means it is a liquid state welding technique. Which is the liquid state welding technique? Brazing, solid or liquid state. Soldering, brazing are solid or liquid state welding. Forge welding is a solid state welding. Now MIG welding is the option. Option C is the correct. Option C is the correct. MIG welding, it is a liquid state welding. Liquid state welding is a homogeneous welding technique. Liquid state welding is a homogeneous welding technique. Okay? Right, right. Good. Please observe it. This you can think of. Regarding fusion welding technique, which of the following statements are correct? Okay, na? So this is a joint. This is a joint. This is a base metal. This is a joint, this is a base metal. So where these forces are coming, can you please look at it? This question, friends, here. Generally, due to shrinkage, the metal will move toward the center. Due to shrinkage, the metal will move towards the center here. So if you look at here, friends, this metal is moving toward the center due to contraction. So contraction, if it is moving toward the center here, the stress developed will be tensile. Stress developed will be tensile. Now in this base metal, the stress developed will be compressive. Because if this metal will be contracting towards the center, base metal will provide some resistance in opposite direction. So base metal compressive stress will be there, and in this joint tensile stress will be there. So what is the option here? Please tell me. Compressive stresses are generated in the parent metal. Correct. Parent metal compressive stress is correct, na? Arey yaar. Tensile stresses will be generated in the weld joint. Correct. Tensile will be in the weld joint. Compressive stresses are generated in the parent metal. So what is the option? Both A and B both are correct here. A and B are both are correct here. A, B are correct. अरे कैसा होता है जी? BD कैसा होता है? Tensile stresses are generated in the weld joint. How compressive stresses will be generated in the weld joint? AB. How BD are? See, In the joint, the metal will be contracting due to solid shrinkage. It is moving toward the center. Once it is moving toward the center, internal resistance is developed now, that is a tensile. Right. If the metal is contracting, base metal will provide some resistance in opposite direction. So if it is opposing this one, due to this the resistance developed here, it is compressive. अरे stress का concept है internal resistance. ठीक है, internal resistance will be developed now. This one. Now can you please think of this question? Yeah, our friends are asking about this one. Please look at numerical questions. Please check it. 1 minute. Yeah, please observe. Linear voltage arc length characteristics, VA equal 20 plus 40 LA. Please look at here. Yes, mentioned 20 plus 40 LA, where LA will be in centimeters. Yes, given. Please look at 40 means, please observe, it is a little bit high value. Means your arc length should be centimeter. If it is 4, arc length will be in mm. If this constant is 4, arc length will be in mm we can consider. So he is saying that friends. Alright, open circuit voltage 80 volts, short circuit current is what? 400 amperes. Okay, can we use a shortcut method? He is asking maximum power, maximum arc power, and he is given linear arc voltage characteristics is given now. VA characteristics is linear given, and please think of maximum power condition is given. So I will use the shortcut method friends here. Vt equal to V0 by 2, It will be equal to Is by 2. So V0 by 2, 80 by 2, it will be equal to 40 volts. Is by 2, 400 by 2, it will be equal to 200 amps. Determine the voltage and current for obtaining maximum arc power, and optimum arc length is also obtained. Voltage and current for maximum arc power means this one, 40 volts and 200 amperes. So if you want to calculate the power also, you can calculate power equal to 40 into 200. So it is how much? 8 kilowatt na, right. So regarding voltage friends here. So what is the stable arc generation condition? Arc length to determine stable arc generation is Vt equal to Va. Vt will be equal to Va, stable arc generation condition. So Vt equal to Va, Vt is 40 volts, Va is 20 plus 4 LA. So from here, if we solve here, arc length will be equal to 0.5 centimeter. Arc length is will be 0.5 centimeters. Correct? Arc length will be 0.5 centimeters. 40, 200 and 5. It's not 5 mm friends here, 0.5 centimeters, or you can consider arc length will be, arc length will be equal to how much? arc length will be equal to 5 mm or 5 centimeters. 5 mm or 0.5 centimeters. Voltage is 40, current is this one, this much. Okay, na? Yeah, this one. We check this question here. Heat required to melt a given volume of the metal is given as the equation, where Um is energy in joules per mm cube, Tm is melting temperature in Kelvin. For welding steel with a melting temperature of 1470 Kelvin, heat transfer factor of 0.6, the cross sectional area of the welding speed is given, rate of energy required to be delivered by the welding equipment. Rate of energy required to deliver by the welding equipment means indirectly we need to calculate the power, that is V and I. How much is the power we have to supply, that is voltage, and rate of energy means joules per second. So many watts na. So this is joules per second, so many watts we can consider. Joules per second, so many watts we can consider. Okay? So here, but he has not given heat required melt, friends. Heat required to melt is given, that is using the formula 4 into 10 power minus 6 into Tm square. Tm is melting temperature in degree Kelvin. How much melting temperature he has given? 1470 degree Kelvin. So this is the energy required. What are the units here? Joules per mm cube. Joules per mm cube he has given, friends. Yeah. Joules per mm cube. 8.64 joules per mm cube. And one more twist in this problem, please look at here. Directly heat required to melt is not given. First point. Second point is, please observe here, he has not given melting efficiency, friends, here. Heat transfer factor as given. Heat transfer factor, please think of heat transfer factor of 0.6. Heat transfer efficiency is given 0.6, but he has not given melting efficiency is not given. If melting efficiency is not given, by neglecting the heat transfer losses, by heat required to melt equal to heat supplied, I will consider. Heat required to melt equal to heat supplied by neglecting losses. By neglecting losses, heat required to melt equal to heat supplied we have to consider. So heat required to melt is so many joules per mm cube. Heat supplied also so many joules per mm cube I have to consider. So this is a V into I by area welding speed multiplied by heat transfer efficiency of the arc. Heat transfer factor means heat transfer efficiency, is not melting efficiency. So from here we need to calculate V into I. What is this one? 8.64 will be equal to V into I we have to calculate, friends, here. Area 10 mm square, welding speed is 5 mm, it is 0.6. So from here, please tell me what is the power that is equal to V into I, that will be equal to how much? 720.3, very good. 720.3 watt, so many watt, very good. 720.3 watt. 720.3 watt. $720.3 watt. Good. Yeah, next you can see. Two mild steel plates of 1 meter length are butt welded using a power source of 40 volts and 450 amperes while welding 6 electrodes of diameter 4 mm and length 450 mm are used. If melting factor, process efficiency, heat required to melt electrode are 30%, 35% and 10 joules per mm respectively, then welding speed is how much? It's a very, very good question, friends. Please think of this question. I will draw the figure. I will explain the concept. Please learn the concept, friends. Please learn the concept. Okay, na? Please look at this point, friends, here. See, to produce this particular area of the joint to produce, is saying that, friends, how many, please, electrodes he is using? 6 electrodes he is using. Diameter is this one. So can I find volume of each electrode? Can I calculate? Volume of each electrode can be calculated. Multiplied by 6 will give total volume of the metal which is entered by melting the electrodes. And he has given length is 1 meter. So 1000 mm length is this direction. This is a 1000 mm. 1 meter length he has given this. So first here I can calculate volume of the joint. So please think of volume of the joint. This volume of the joint is produced by using how many electrodes? 6 electrodes. What is the diameter of the electrode? 4 mm whole square into 450. So this is the volume of the joint. Here I am assuming that total joint is produced by supplying the filler material only. In the joint I am assuming that there is no base metal is melted. Are fusion welding mein base metal is also melted na? Joint is produced by melting the base metal also. But here the condition is, I am assuming base metal is not melted. Because I don't know in a volume of joint how much of base metal, how much of the filler metal, I don't know. That's why the total joint is produced by supplying the electrode metal only. By supplying the filler metal only, the joint is produced. So initially gap is there between the two work pieces. This gap is getting filled by using the electrode only. That gap is getting filled by using the electrode only. Are you getting me? This is the volume of the joint. So I want to find out area of the joint. Area of the joint, you consider here, friends, volume by length. Volume by length. So 6 into pi by 4 d square into 450 by length is 1000. So then you are getting, friends, area of the joint is how much? That is mm square. Area of the joint you are getting is in how many? Please think of mm square. You are getting 33.912 mm square. Area of the joint is 33.912 mm square will be the area of the joint. Area of the joint is 33.912 mm square. Next, what is required to calculate? Welding speed is required. So can I use the formula? Melting efficiency equal to heat required to melt by heat supplied. Heat required to melt units are given joules per mm cube. Same I am using heat supplied also. So can see heat required to melt by V into I by area welding speed multiplied by heat transfer efficiency of the arc. Right. So from here I am going to calculate welding speed. So melting efficiency is given, friends, 0.3. Heat required to melt is given 10 joules per mm cube. Voltage 40 and 450. Area of this weld bead is given, we just now we have calculated 33.912 multiplied by welding speed multiplied by heat transfer factor, it is 0.85. So from here you tell me what is the welding speed. What is the welding speed? Arey, acha ji, you are very good in numerical. 13.53 mm per second. Correct? 13.53 mm per second. 13.53 mm per second. Very good, very good. 13.53 mm per second. 13.53 mm per second. Okay, good. This is correct na? 6 electrodes, consumable electrode length and diameter is fixed na. So 6 electrodes they are using. So this is the volume of each electrode I am considering. Multiply by 6 will give total volume of the joint. Here the assumption is Joint is produced by supplying the metal by using electrode only. By supplying the metal from the electrode only, we are expecting the joint. Okay? Right, very good. Yeah, please observe this point, friends. Yeah, this question. If the current at 100% duty cycle is 250 amps, then what should be the required current for 50% of duty cycle? Friends, so duty cycle current relation is given by this equation. I square D equal to constant. So please here, I equal to current, D equal to duty cycle. Okay, this you can observe. So if you are using here, I1 square D1 will be equal to I2 square D2. I1 square D1 equal to I2 square D2. Right, please take out. Here first one is 100% duty cycle with a current of 250 whole square into 1 equal to I2 square D2. D2 is 0.5. From here, what should be the I2? What should be the I2? I2 is how much? Current. They are given very closely. Answers are given very closely, my dear. Answers are given very closely. Very good. 353. 353.55 amps. 353.55 amps. 353.55 amps. Correct? Good. Right. Which of the following statements are true? True statements, please tell me, friends. Sometimes theory questions also please observe, because gate mein theory questions bhi aata hai na. So how the questions will be giving, where the twisting is given, please apply. This is true. In TIG welding, consumable electrode is used. No, non-consumable electrode is used here. In GMA means what? MIG welding. GMA means MIG welding. Both AC and DC power supply can be used. Yes, it can be used. AC can be used, DC can be used. Cleaning of the oxides hota hai, right? SA means submerged arc welding is not used for mass production. It can be used for mass production. Submerged arc welding, high thickness objects we are joining at a high welding speed. High thickness objects at high welding speed we are using. Submerged arc welding can be used for mass production. But he is saying that is not used. That's why it is a correct statement. Plasma arc welding, depth of penetration is more. It is correct. More depth of penetration will be there in case of plasma arc welding. So B and D will be the correct option. B and D will be the true statement. True na? True statement. B and D will be the true statement. Correct? B and D will be the true statements here. Both AC and DC can be used. Plasma depth of penetration is more. Can you please look at here? Yeah. Somebody is saying A. TIG welding consumable electrode use कर सकता है? No. अरे tungsten electrode is non-consumable electrode है ना? Tungsten electrode is non-consumable electrode है ना? BD is correct. How A is true? True statements is बोलता है ना? TIG welding consumable electrode is used. Tungsten means it's a non-consumable. TIG क्या है? See, why I am intentionally giving is these notations they are giving in gate examination. Gate examination, these notations are giving TIG welding, JITA, GMA, SAW, SA, or we can say plasma arc welding, PAW, like these notations are giving. That's why I am giving intentionally this notation. TIG welding means tungsten inert gas welding. GMA means MIG welding, submerged arc welding, plasma arc welding. Correct na? Oh, right. Last question he has given. Okay. Right. Please check. Right, correct. So B and D will be the correct option. Last question answer A. Okay, fine. B and D will be the correct option. Correct here. B and D are correct. Yes, yes, very good. P and D both are correct, na? Yes, very good, correct. Correct, na? Right. This question you can observe, friends, here. 10 liters of acetylene is consumed from cylinder for welding of brass. How many liters of oxygen is consumed from oxygen cylinder? How many liters of oxygen is consumed from oxygen cylinder? Oxygen cylinder. Please check this question, friends. It is a brass material. Please observe, application is required here. Brass material, gas welding, oxyacetylene welding, gas welding for copper, zinc, brass and bronze. Copper, zinc, brass and bronze can be welded by which flame? Oxidizing flame. Which flame we are using, my dear friends, here? Oxidizing flame. Oxidizing flame. See, if it is a mild steel, it's neutral flame. Neutral flame में oxygen acetylene ratio both will be same. But it's the oxidizing flame. Oxidizing flame मतलब क्या है? Oxygen to acetylene ratio from the cylinder is 1.15 to 1.5. 1.15 to 1.5. Oxygen to acetylene ratio is 1.15 to 1.5. See, this ratio is from the cylinders only. This ratio, volume of oxygen to volume of the acetylene consumed from the cylinders. Okay. See here, from the cylinders, how much will be the consumption we can consider? So, acetylene consumption was 10 liters. Then what is the oxygen consumption? Oxygen consumption is more, na? So, oxygen consumption will be 1.15 into 10 liters from the cylinder. 1.5 into 10. So, here please observe, friends, oxygen consumption is 11.5 to 15 liters. 11.5 to 15 liters. This consumption is from the cylinders only. How many liters of oxygen is consumed from oxygen cylinder? From the cylinders I am considering, my dear friends. It is in the range. Neutral flame, please, ratio will be same, na? Neutral flame में ratio 1 है. But here ratio is 1.15 to 1.5. It will be in the range. Right. It will be in the range, my dear friends. It will be in the range 11.5 to 15 liters. So here ABCD options are not given. If ABCD options are given, which is close to this one? The answer ABCD options, which answer is given in between 11.5 to 15? In between 11.5 to 15, which is the option that we have to consider? Which is the option that we have to consider? समझ में आता है ना? Please check the material here. Brass. Sometimes let us say high carbon steels is given, cast irons are given. Then we have to consider what? Right, carburizing flame. Carburizing flame we are using. Carburizing flame में oxygen to acetylene ratio क्या होता है? It is 0.85 to 0.95. Please check what is the application. Which material we are welding? Which material we are welding? By using gas welding technique. So, high carbon steels cast iron means carburizing flame here. Copper, zinc, brass, bronze means oxidizing. Remaining neutral flame. Neutral flame ratio is 1. 10 liters only. Correct, na? Yes, very good. Cast iron reducing or carburizing flame we are using. It will be in the range, my dear friends. It will be the range 11.5 to 15 liters. It will be in the range 11.5 to 15. For example, in the options given, 13 is given, 13 you can select, or 14 is given, 14 you can select. Okay na? Right? समझ में आता है ना? Very good. This you can observe, friends, here. Who is going to give the answer for this? Because repeatedly this question is asking, friends. In GATE and other PSUs also this question is asking repeatedly. Two sheets of same material but different thickness can be spot welded by. Two sheets of same material but different thicknesses can be spot welded by. It's not arc welding, it is a spot welding, means resistance welding. Resistance welding ke baare mein, can you please tell me what is the answer? What is the option for this one? Please tell me. Two sheets of same material but different in thickness. Different in thickness can be spot welded by. It is a resistance welding. Spot welding, it is a resistance welding, my dear. Resistance welding. Resistance welding, please read the question. It is a resistance welding. Spot welding means resistance welding, na? Spot welding, different thickness of the workpieces metals can be joined by changing the size of the electrode or changing the diameter of the electrode. Changing the diameter of the electrode. See, if you have less thickness and high thickness, different materials are there. Less thickness and high, small thickness, different materials are there. So if you have different materials, T1, T2, different thickness are there, my dear friends. क्या होता है? Now, here if you are generating heat generated will not depends on thickness. Heat generated will depends on what? Are contact area and what? Time. Heat generation will depends on contact area, contact resistance. Heat generation will depends on I square RT. R is a contact resistance, T is a time of supply, I is a current. Heat generation will not depends on thickness. Heat generation will not depends on thickness. So if you are generating heat, friends, here, heat dissipation में थोड़ा दिक्कत होता है. Due to difference in thickness, heat dissipation में थोड़ा difference आता है. Heat difference, please think of it. So if you look at closely, if heat distribution में थोड़ा difficulty होता है, that's why. Please look at here, because if thickness is more, heat transfer along the higher thickness will be less. After melting होने के बाद, after the pressure is applied, joint होने के बाद, liquid metal solidification होता है ना, इसमें दिक्कत होता है, because heat transfer has to be there. Higher thickness heat transfer will be less. Lower thickness heat transfer will be more. Heat transfer is more. So from this direction heat transfer is more, from this direction heat transfer will be less. So I want to increase the heat transfer rate in this particular direction. I want to heat in this direction, heat transfer will be less. Heat transfer here will be less. Heat transfer here will be less higher thickness. Heat transfer here has to be more. So if you want to increase the heat transfer here, I will provide diameter D1, diameter D2. So D1 will be greater than D2. By providing more diameter of the electrode, I will increase the heat transfer rate from higher thickness of the workpiece. If you are increasing the heat transfer from higher thickness of the workpiece, so both direction heat transfer will be same, so that we are expecting uniform joint formation can be taking place. Uniform joint formation can be takes place. Heat generation will be there, friends. It will not depends on thickness. It will not depends on thickness. Heat generation will depends on current, resistance and time. With respect to thickness, heat transfer difference होता है. Higher thickness, less transfer. Less thickness, please, more heat transfer will be there. Heat transfer is indirectly proportional to thickness now. Now I want to increase the heat transfer at higher thickness. To increase the heat transfer at higher thickness, if you provide more diameter of the electrode, more heat transfer is there. Here already heat transfer is more with respect to thickness. Even if you provide small diameter also, heat transfer is there. By increasing the diameter here, we can increase the heat transfer rate. So that uniform joint formation is there. It is in case of resistance welding. Resistance welding, if the different thicknesses are there, diameter of the electrode we have to change. Provide a large diameter of the electrode at higher thickness of the workpiece. This is a point. For example, in arc welding, heat generation will depends on current. Please think of. Here thickness is more, I want to generate more heat, more amount of metal has to be there. So thickness is more, I will increase the current. If you are changing the thickness, I am changing the current. So if it is adjustment of the current, in case of electric arc welding, it is with respect to adjustment of the current. Resistance welding, it is changing the size of the electrode. Changing the size of the electrode. D is the option here, friends. See here, your heat generation will not depends on thickness. अरे contact resistance में heat generation होता है ना? Heat generation is same, thickness is more or less also. Difference is coming with respect to heat transfer. So I want to make it uniform heat transfer, my dear. Uniform heat transfer I want to make it. Okay na? Okay? So this will be the option in resistance welding. If it's arc welding, adjustment of the current. Adjustment of the current in arc welding. Now please check it this question, friends, here. In spot welding, two sheets each of 1 mm thickness are joined by using 10 kA welding current for 0.35 seconds. Assuming interface resistance is 100 micro ohm, heat required to melt the metal is 10 joules per mm cube and heat loss to the surroundings is 1000 joules. Volume of the weld nugget is how much? Volume of the weld nugget is how much? Now first I will calculate, friends, heat supply. I square RT. Current 10,000 whole square. 10 kilo amps. Resistance 100 micro. 10 power minus 6. Time is 0.35 seconds. So how much you are getting, my dear friends, here? I think it is 3500 joules or 3500 joules. Heat supply. Heat loss to the surroundings is how much? 1000 joules. So heat lost will be equal to heat supplied minus heat required to melt. So what is the heat lost? He has given 1000, 1000 joules he has given. Heat supplied is 3500 minus heat required to melt. So from here, heat required to melt equal to 2500 joules. This is heat required to melt. Next, he has given heat required to melt per unit volume. He has given heat required to melt per unit volume is given. So if you want to calculate volume of the nugget, heat required to melt by heat required to melt per unit volume. So that you are getting volume. So this is 2500 by heat required to melt per unit volume is 10. So it is 250 mm cube. Volume of the nugget is 250 mm cube. Very good. Yes. Yeah, please look at this question. It is with respect to seam welding. Seam welding के बारे में. Very good question. Who is going to give the answer for this one? Please check it, friends. Read the question carefully. He is saying that here, how many nuggets are produced per centimeter, friends, here? 4 welds per centimeter. 4 welds per centimeter is said, friends. Number of welds per centimeter. Number of welds per centimeter. Number of welds per centimeter will be equal to 4 welds per centimeter. is asking what is the diameter of this particular electrode, friends. Diameter is given, no, RPM of the electrode. It is a roller, na? A roller type of electrode we are using, RPM we have to calculate. So 4 welds is given for centimeter, and he has given, please think of, in seam welding, power supply is on and off like this. It is a pulsed power supply because we are continuously rotating the roller, and power supply is given not continuously, it is a abrupt power supply, on off like this we can. So he is saying that the frequency is 50 hertz, 3 cycles are on, 2 cycles are off. 3 cycles current is on, 2 cycles current is off in a frequency of 50 hertz. 3 cycles on, 2 cycles it is off, we can consider. Okay. So from he has given frequency, from here I want to calculate, please think of number of welds per minute. Number of welds per minute. So if you are supplying the current per minute, how many welds we are going to produce, I have to calculate. For which, please look at the board. Frequency divided by, now we can see number of cycles on, no? Cycles for weld, cycles for weld means how many cycles are on, plus what is the, please, off, cycles for off, how many are off, how many are on, this is we have to consider. This is the frequency. See, frequency has given hertz, friends. Hertz means what? Per second, na? Hertz means per second. Per second I want to convert them into minute. Number of welds per minute I have to calculate. So this is 50, frequency is given 50 hertz, that is per second. Per second means second divided by 60 will give what? Minute. That's why I am going to multiply with 60. So why 60 is coming? Seconds is converted into minute. Seconds by 60 will give minute. So because frequency has given 50 hertz. Okay, this one. So this formula, please, number of cycles on, number of cycles off. Off means we can say, friends, what? It is a ideal cycle. On means it is a weld cycle. So if you want to calculate number of welds per minute, here this is frequency is given 50 and it is 60 by how many welds are on? 3 plus 2, we can consider, friends, it is 5. So how many you are getting, friends, here? It is 600 welds per minute. 600 welds per minute we can consider, my dear friends. Okay, na? So now we have calculated, friends, number of welds per centimeter, number of welds per minute. So I want to calculate linear welding speed, workpiece welding speed, because this workpiece is moving in this particular direction, na? So welding speed, linear welding speed will be equal to number of welds per minute, by number of welds per centimeter, So if I am calculating number of welds per minute, number of welds per centimeter, number of welds per minute 600 by number of welds per this one, this is 400. So how much we are getting, friends, here? So 150, correct, na? 150 welding speed, it is centimeter per minute. So number of welds will be cancelled out. This is minute, this is centimeter. Centimeter per minute we are going to consider. So this is a linear welding speed. This linear welding speed will be equal to angular rotation of this roller, na? That is electrode. So here V equal to pi dn. I am considering here. Pi dn. So V is 150 centimeter per minute. Pi. What is the diameter as given? 220 mm. This is centimeter. So 22 centimeter into rotational speed n. So what is the rotational speed? Please tell me. What is the rotation? Because this linear welding speed of the workpiece will be equal to rotational speed of the roller. So what should be the n value? What should be the N value here? It's a good question. It's related to seam welding, seam welding. In workbook we have solved, friends. Directly as given number of welds per minute, directly as given in the problem. But here, if a power supply is given, on, off, power supply is given, then we have to remember this equation. Frequency multiplied by 60, number of cycles on, number of cycles off. This formula please try to remember. This formula please try to remember. To calculate number of welds per minute, then welding speed, linear welding speed equal to number of welds per minute by centimeter per minute. So this linear speed of this workpiece equal to rotational speed of the roller. Rotational speed of the roller. Rotational speed of the roller is pi dn. Rotational speed of the roller is pi dn. D is the diameter of the roller. N is the rotational speed of the roller. So N value will be equal to 2.17. 2.17 RPM. 2.17 RPM. Centimeter per minute na, this you are getting RPM 2.17. So the roller is rotating at a rate of 2.17 RPM. 2.17 RPM. Clear? This type of questions can be expected, friends. There are different questions because they have to frame new questions ना, new questions ऐसा आता है, ठीक है? Yeah. Projection welding is a, please read the question. Projection welding is a continuous spot welding. Please observe. Continuous spot welding is what? It is a seam welding. Continuous spot welding is called seam welding. Projection welding is a multi-spot welding technique. Projection welding is a multi-spot welding technique. It is a multi-spot welding technique. Option B. अरे करेक्ट ना? क्या वो समझ में आता है? Multi-spot welding technique. Projection welding में look at here. This is the two work pieces you are joining. Multi-spot welding technique na? Very good. Yeah, next you can observe, friends. The correct statement pertaining to friction welding. Pertaining to friction welding. Friction welding. The correct statement, please look at. Correct statements is asking, friends. Friction welding. Please saying friction welding, two workpieces will be rotating at the surface, at the contact surface. They are going to make the joint by friction. Heat affected zone is formed. Yes, heat affected zone is formed. Small heat affected zone will be there. It is used for joining of flat work pieces. It is not used for flat. Flat means, plates means it is a friction stir welding. It is used for friction stir welding is here. Friction welding used for axisymmetric objects only. Cylindrical shape of the objects only we are using by friction welding. Dissimilar materials cannot be joined. Please think of dissimilar materials can be joined. That is the advantage of friction welding. Solid state welding, can we join dissimilar materials now? Melting of the base metal is not involved, is correct. Friction welding, we are heating, let us say red hot condition, above the recrystallization temperature we are heating, but it should not be melting. There is no melting of the metal in friction welding because it is a solid state welding. Na? Friction welding is a solid state welding, there is no melting of the base metal is involved. So A and D both are correct. It is not used for flat surface of the workpieces. Dissimilar metals can be joined. Please observe this point. Please observe. A and D are correct na? C. Priyanshu, why see how dissimilar metals cannot be joined? Yes, we can join. Solid state welding, dissimilar metals can be joined. solid state welding, dissimilar metals can be joined. We are not melting the material. D also correct. Melting of the base metal is not involved. Yeah. So what I observed, my dear friends, you are good in numericals. Very good. I am happy with that. But at the same time, GATE examination theory questions bhi aata hai. So answering the theory question dikkat hota hai. Numericals you can solve easily. That's good. But theory maybe you can just concentrate here because theory is also required in GATE. Okay? Because production mein answering theory question thoda dikkat hota hai. So you have to think properly, friends. You have to think properly. Yes, yes, very good. Right, right. Just think of it. This is a good question. Right. Which of the following welding technique heat affected zone is more? He is saying more, friends. High value. Heat affected zone is more. If heat concentration is less, heat affected zone is more. If heat concentration is more, heat affected zone will be less. So you can think of it. Now it is more. Heat affected zone is more with submerged arc welding. Submerged arc welding, heat affected zone is very high. So submerged arc welding, it is very high. So sometimes they are asking ascending order, descending order also. If you want, you can write down. Submerged arc welding, it is very high. Then later it will be there, in which case TIG welding, GTA, gas tungsten arc welding. It will be later than what? Plasma arc welding. Then later it will be laser beam welding. Okay, laser beam welding, heat affected zone बहुत कम होता है because heat concentration is at a small area. Heat concentration is at a small area. I am not audible. अरे यार क्यों? Why? Ritik mechanical. I am not audible. क्यों? I think mic is on only. Mic is on only. I am audible now. Please check it, all of you. Am I audible or not? Am I audible or not? Okay, good. Right. Regarding defects, welding defects are considered. Gas porosity, hydrogen embrittlement, lack of fusion, splashing. Gas porosity is coming because of what? Trapping of the gases in the joint. Hydrogen embrittlement is diffusion of hydrogen gas. Lack of fusion, insufficient heat input. Splashing, splashing is coming due to arc blow also. Liquid metal is getting splashed. Arc blow can be formed. So we'll see here A4, A4, B, B3, C1, D2. 4312 correct? Yes, very good. 4312. 4312. Very good. This is related to defects. So with this we will close the welding. Then we will go to friends forming. Very interesting questions we will discuss. As you are asking about more numericals, we will discuss about more numericals with respect to forming. Just you can see this sample question of theory. Sample question. Which of the following are the characteristics of a hot working process? Hot working process characteristics. Hot working, close tolerances can be produced. No. Oxide formation is there, shrinkage will be there, rough surface will be there, no dimensional accuracy. Close tolerances can produce. No. Less force are required, correct. Operating above recrystallization temperature, less force are required. Cracks will be formed. No cracks. Because in hot working, at each and every point, recovery, recrystallization and grain growth will be there. If any stress will be there, that will be relieved. There is no strain hardening, there is no crack formation in hot working, that is the advantage. Strength is increased, yes, strength is increased. Hot working, cold working, in both cases strength is increasing. But cold working strength is very high because of strain hardening. Here strain hardening is not there, but till then there is a chance of increasing the strength in case of. So what is the option, friends, here? B and D will be the B and D will be the correct. Very good. Strength decreased, ductility increased. Arre yaar, strength is not decreasing always, yaar. See, you are taking If you are heating the material, please observe, if you are heating the material, strength is decreased and ductility is increased. Okay ना? अरे आफ्टर वर्किंग होने के बाद क्या होता है? स्ट्रेंथ इंक्रीज होता है ना? आफ्टर हॉट वर्किंग होने के बाद, इफ यू आर हीटिंग, strength will be decreased and you can say ductility is increased. If you are heating, it is happening. Yes, grain forest diode, BD. Yes, BD is correct. Correct. Yeah, next you can please think of it. The true stress strain relation for an engineering metal is sigma T equal to 300 epsilon to the power 0.2 megapascals. The true stress of the material after 40% of cold work, after 40% of cold work, 40% of cold work. So this 40% of cold work means, this 40% of cold work means, friends, here, this is 40% of cold work means what? Reduction in area. Reduction in area. Reduction in area. So how much reduction will be there? So percentage of reduction will be equal to, right? This 0.4, friends, here. This is A naught minus AF by A naught. This is a 0.4. It will be equal to 1 minus AF by A naught. Okay. So from here, AF by A naught will be equal to 0.6. AF by A naught will be equal to 0.6. So if you want to find out, friends, a true strain equal to ln A naught by AF. A naught by AF. So true strain will be equal to ln, right, AF by A naught, no, 1 by 0.6. So what is the true strain? If you know true strain, then you can find out sigma T will be equal to 300 epsilon to the power 0.2. So tell me what is the true strain here? Very good. Are this fast? Why? You are very fast. 0.5 Anna. So true stress will be equal to 262.29. Very good, all of you. Very good question, very good. You are giving answer quickly for numericals, right? Now, this question please think of. This question you can determine the value of the strain hardening exponent for a material that will cause the average flow stress to be 3/4 of the final flow stress after the deformation. Final flow stress after the deformation is K epsilon to the power n. Final flow stress after the deformation. At the end of maximum flow stress will be given by this one. What is the average stress? Sigma average will be K epsilon to the power n by n plus 1. Average stress will be given. Average flow stress to be 3/4 of final flow stress. So average flow stress will be equal to 3/4 of final flow stress. This as the condition has given, friends. So sigma average will be K epsilon to the power n by n plus 1 will be equal to 3/4 by flow stress is K epsilon to the power n, we can. Okay na? Right. So K epsilon to the power, it will be getting cancelled, friends. So that what happen? 3 into n plus 1 will be equal to 4. 3 into n plus 3 equal to 4. So n equal to 1 by 3. 0.33. Strain hardening exponent is 0.33. Yes, very good. Strain hardening exponent is this one. It is a flow stress, friends. Flow stress. We are finding average stress. Look at here. I will explain 1 minute. Look at this point. Let us say if I am drawing the material, friends, so through the die if I am drawing here, so maximum stress will be sigma F. Initially it is a sigma Y, right? Stress will be increasing here. So flow stress is the final stress. Initially it is a yield strength. In between we are finding sigma average. समझ में आता है ना? Yeah, please look at here. In a forming operation, the plastic deformation of a specimen starts under plane stress condition where the principal stresses are sigma 1, sigma 2 as given. If the specimen follows von Mises yield criteria, then the uniaxial tensile yield strength of the material. Uniaxial tensile yield strength of the material means indirectly flow stress is asking. So we know that formula, friends, here. Sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square, sigma 3 minus sigma 1 whole square will be equal to 2 times sigma naught square. It is von Mises theory. For ductile materials, we are using the two theories of plasticity. One is Pressurized theory, second one is von Mises theory. These two theories we are using for ductile materials. Theory of plasticity. So sigma 1, sigma 2 is given, sigma 3 is not given, friends. So you can cancel the sigma 3, sigma 3 is 0. So sigma 1 minus sigma 2, 200 minus 100 whole square plus 100 minus 0 whole square plus 0 minus sigma 1, 200 whole square equal to 2 times sigma naught square. From here, what is a sigma naught? He is asking von Mises theory. Forging, we have discussed this point, friends. Sigma naught is how much? One 173.2 megapascals. Right, this part. Uniaxial tensile yield strength means this is a flow stress. Up to elastic limit, you are discussing yield strength. In plastic region, we are discussing flow stress of the material. ठीक है ना? Yeah, this one. In a single pass rolling operation, if the coefficient of friction is doubled, keeping other parameters the same, then percentage change in the draft will be. What is the draft actually in rolling draft? Delta H will be equal to initial thickness, final thickness will be equal to mu square R. So delta H1 initially it is mu square R. So second case क्या होता है my dear friends? Second case is saying that mu is increased by how many times? If the coefficient of friction is doubled, keeping other parameters same, means radius is same, he is only increasing what? Coefficient of friction, that is doubled, 2 mu whole square multiplied by R. So it is 4 mu square R. So this will be equal to 4 times of delta H1. 4 times of delta H1 we can consider. So delta H2 equal to 4 times of delta H1. Percentage change in draft will be equal to delta H2 minus delta H1 by delta H1. Change na? Into 100%. So delta H2 by delta H1 minus 1. Four times of delta H1 by delta H1 minus 1 into 100. So it will be equal to 300%. Correct? 300% correct? Very good. Very good. 300% is correct option. Yeah, this we can observe, friends, here. A 5 mm metal strip is required to be hot rolled to 4 mm thickness. The width of the strip is 100 mm. The flow stress of the sheet metal and torque per roll are torque per roll. Read the question carefully. Torque per roll 250 megapascal and 5000 Newton meter respectively. Then roll diameter is how much? Roll diameter is how much? So as given, friend, delta H is how much? You can check it. Delta H equal to H0 minus HF, that is 5 mm, na? 5 minus 4, it will be equal to 1 mm. It will be equal to 1 mm. Okay, na? So please look at here. No, if nothing is mentioned, see it hot rolling is given, na? Right. So torque equal to what we can say, my dear friends, here? What is that? Roll separating force. Roll separating force. Torque is roll separating force multiplied by arm length, arm length. What is arm length? 0.5 times of LP. 0.5 times of LP. What is the force here? Force is sigma naught flow stress multiplied by projected area into 0.5 times of LP. Projected length, projected area. What is projected area? Width multiplied by length, projected length. Width multiplied by projected length. Sigma naught into B into LP into 0.5 times of LP. Here, friends, LP do not there. What is LP, friends? Projected length. Projected length equal to R delta H. R delta H. From here we need to find out radius. R delta H. LP square hai na. Now torque equal to sigma naught into width multiplied by 0.5 multiplied by LP square. LP square is what? R delta H. From here we need to calculate R. Radius we have to find out here. What is asking? Roller diameter is asking. Okay. This the torque is for single roll. Torque per rolling we can consider. It is a torque for roll is 5000 Newton meter. Sigma naught is 250 megapascals. What is the width of the workpiece? 100 mm into 0.5 multiplied by R. Delta H is 1 mm. So this we are substituting, friends, here in mm. Okay, na? So that's why I am dividing with what? 1000. Because we are substituting in Newton meter hai na? Meter we have to substitute this one. So this is stress multiplied by area will give newtons. Meter means this we have to substitute in meter. From here what is the radius? From here you can tell me what is the diameter. Yes, very good, very good. Yes, very good. What is the radius? Yeah, you have calculated first radius, then you can tell me what is the diameter. Radius is 400, very good. He is asking a diameter, friends, 800 mm. Good question, na? Right. So reverse way. See, questions are coming. Calculate the torque, calculate the roll separating force, calculate the power required in rolling operation. This is one way. Reverse way. When torque is given, how to calculate the diameter? Reverse way, can you please think? Reversely, you can think like this. Reversely, can you please think like this? Okay, yes, yes, very good, very good. Numericals you are doing very quickly, there is no doubt. Very good. Gate examination success is this one, very good. Yeah. This question एक बार check करो जी. Already you know this one. Hey यार, exponents means there is no friction at all. अरे कैसा होता है जी? कैसे होता है जी? अरे यार, pressure distribution कैसा होता है जी? Let us say exponential increase or exponential decay will be there. It is what type of here? Sliding है ना? Sliding will be there. Sliding will be there. Sliding. Exponential increase or exponential decrease means what is there? Sliding will be there. Sliding will be there. Exponential form increase, exponential decrease means sliding. Linear means it is what? Sticking. Linear means what? It is a linear. So it is a sticking. Both are there means sticking and sliding both will be there. Both are there means sticking and sliding both are there. So in open die forging, circular disc, okay? The exponential decay of normal stress on the flat face of the disc, exponential increase, exponential decrease. From the center, if you see that, it will be decreasing both sides if you are observing from the center. Okay, so it is what type of friction here? Sliding. Here what is there? Linear means sticking, exponential means sliding. Okay, now please here there is no sticking friction anywhere. There is no sticking means what will be there? Sliding will be there. If there is no sticking friction at all means only sliding hota hai na. Are any one type of friction has to be there or both has to be there. He is saying that there is no sticking at all. So definitely what will be there? Sliding friction hone wala hai. ठीक है ना? Sticking friction and sliding friction both are there. No, both means linear and exponential both has to be there. Both has to be there. The flat face of the die is frictionless. No, it is not possible. What is the option A? Yes, there will be no sticking, only sliding will be there, only sliding. This type of theory questions, they will confuse you at all. Please read the question carefully and you have to answer. This question, please look at friends here. Yeah, forging, you have to think up to this level friends. There is no need to go beyond this particular scope. Sticking length calculation, sticking radius calculation, what type of friction will be there, what type of pressure will be there, that we have to think. Okay, now this is very important, it is required. A 200 mm, please initial dimensions you can think 20, 20 and 160 mm. So it will be forged to which one dimensions? Final dimensions are 10, 40 and 160. So forging is a plane strain condition. Plane strain condition forging. Which dimension is constant? Width. So from initial to final, which dimension is constant? It is a width. So this is the width I am going to consider. Which dimension is decreasing? That is the height. Forging operation. Compressive load you are applying na, height will decrease. This is what? Length. But length we are considering 2L, my dear friends. So 2L. Pura length we are assuming 2L na. So total length is 2L we are considering. So from here 0 to L we are considering. So we are analyzing up to this one. So by integrating 0 to L we are finding the force. Then It is a mirror image, symmetry, that's why we are multiplying with the 2 times. We are multiplying with what? 2 times. Mirror image, na? So that's why total length we are assuming as what? 2L. For easy analysis we can consider. Okay, 2L. So 2L will be equal to 40, right? From here, L will be equal to 20 mm. So coefficient of friction is also given, friends. Kitna given coefficient of friction is given? Coefficient of friction is given how much, friends? 0.2. So what is asking? Determine the minimum forging pressure. Minimum forging pressure is asking. Maximum pressure, minimum pressure. So first we need to calculate whether it is a sticking or sliding, what type of friction will be there, for which I am using sticking radius. Sticking length. It is a rectangular bar forging. Sticking length XS. Sticking length XS will be equal to X minus H by 2 mu ln 1 by 2 mu. Sticking length formula I am using, my dear. L minus X equal to L minus H by 2 mu ln 1 by 2 mu. What is the length here, friends? Length 20 minus height. Height is how much? 10 by 2 mu. 2 into mu. Mu is a coefficient of friction, that is 0.2 ln 1 by 2 mu. 2 into 0.2 ln. So what is the value? Please tell me here now, friends. What is the sticking length you are getting? Positive or negative? Yes. No integration is required. Only pressure, na? Is asking pressure. Force is there, integration is required. Please revise that. Force is there, integration is required. We are calculating pressure, friends. Pressure multiplied by area, limits from 0 to L means you are calculating the force, where integration is required. Integration means it will take more time. They are asking in gate examination up to pressure only. Up to pressure only the questions will be given. Up to pressure only questions will be given. Please tell me XS, what is the sticking length here? Sticking length कितना आता है? अरे, what is the sticking length यार? Sticking length is how much? No sticking length. Yeah. How much you are getting? Negative means how much you are getting? Yeah. Yes, please give the answer. 25.81 minus. So you are getting negative value, please check it. You are getting negative value, please check the answer. Negative means what? Only sliding will be there. Only sliding friction. Means negative is not possible actually, it is an imaginary condition. Negative means only sliding friction is there. Greater than L means only sticking friction is there. If sticking length is more than L, only sticking will be there. If you are getting positive value, both sticking and sliding both will be there. Both sticking and sliding will be there. If you are getting positive value of sticking length. Here you are getting negative, only sliding friction will be there. So what is the minimum, friends? Please look at here. Pressure distribution ऐसा होता है. Sliding means exponential decay will be there. So this is a P max. P max. Minimum pressure is how much, friends? Here minimum pressure is there, right? Minimum pressure is how much you can consider? It is 2K. Sorry, minimum pressure is 2K. You can consider minimum pressure is 2K na. When small x equal to 0, Pressure is maximum at the center, pressure is minimum at the outside. Pressure is minimum at the outside, pressure is maximum at the center. So minimum pressure P minimum will be equal to 2K. P minimum will be equal to 2K. 2K can consider. So K means according to von Mises theory. Nothing is given. I am considering von Mises theory, sigma naught by root 3. So 2 into sigma naught by root 3 I am going to consider. Sir, why sigma naught by root 3? Von Mises theory, nothing is given here. I will follow von Mises theory. It will give better results. So what that means here? 2 into sigma naught. What is sigma naught? Sigma naught is how much he has given? 70. 70 by root 3. How much you are getting? Yeah, very good. 2.907. This is, yeah, very good. This is minus 2.907. So this negative value you are getting here, that value we are not using, friends. Yeah, okay. Whether you have to identify negative type of friction, we can say. If it is negative, only sliding friction will be there. 2 into 70 by root 3 we can say. Minimum pressure is asking. Minimum will be ऐसा होता है ना. Maximum will be at the center. Minimum will be at the end. We can say. Pressure distribution. एक बार अच्छा. Notes पढ़ाओ. Okay. Okay. 80.83. Very good. 80.83 megapascals. 80.83 megapascals of pressure will be there, where minimum at the outside. So pressure is minimum here. Minimum pressure will be here. Maximum pressure is how much? P max will be here. P minimum here, P max here. Okay. P max here, P minimum here. 80.83 is correct. 70 कैसा आता जी? Please check it. Plane strain condition, correct. Plane strain condition, that's why width is same. Width is same. Plane strain condition, width is same. Next, if nothing is mentioned, you can use von Mises theory. Von Mises theory will give better results when compared to Tresca. That's why sigma naught by root T. K is flow shear stress. Flow shear stress. Shear stress in tension. Shear stress in tension. Correct? Okay. This is with respect to what is called rectangular bar forging. Right. Now, if you are using, say, problem for disc, circular disc or axis symmetric object. Circular disc or axis symmetric object. Second case you can observe. A circular disc of lead of radius 150 mm and thickness 50 mm is reduced to thickness of 25 mm by open die forging. If the coefficient of friction is 0.25, what is the radius? What is the radius at which friction changes from sticking to sliding? What is the radius at which friction will be changing from sticking to sliding? That radius we can call it as sticking radius. Sticking radius. That radius is called sticking radius, that is RS. Sticking radius, it is called RS. We have to find out. He is asking sticking radius. And yes, please observe. All forging calculations are based on the final dimension. Please remember this point. All forging calculations are based on the final dimensions. Final dimensions we have to find. Final radius we have to find out here, friends. So can I assume volume is constant here? So pi r naught square h naught will be equal to pi r square h we can consider. Pi r square h we can consider. So pi will be getting cancelled. What is r naught initial? 150 whole square into h naught 50 mm will be equal to r square into h. H is how much? 25 mm. What is the value of r? Final radius is how much? Final radius is how much? 212 point, very good, 212.132. This is the final radius, not sticking radius, my dear. Sticking radius, we are using two formulas here. So what is that? First, sticking radius Rs equal to R minus h by 2 mu ln 1 by root 3 mu. It is according to von Mises theory. It is according to von Mises theory. And what is the Tresca? Sticking radius Rs equal to R minus h by 2 mu ln 1 by 2 mu. This is Tresca. Two formulas are there to calculate the sticking radius itself. If nothing is mentioned in the problem, please use von Mises theory, because from this so you know design of theories of failure you are discussing now. Von Mises theory will give better results when compared to Tresca. So if nothing is mentioned, you can use always von Mises. If nothing is mentioned, I will use von Mises theory. Sticking radius Rs will be equal to R 212.132 minus height is 25 by 2 mu. Mu is 0.25, coefficient of friction. Please check the units, my dear friends. ln 1 by root 3 mu. Mu is 0.25. Sticking radius is how much? Sticking radius is how much? Sticking radius is how much? 170.28. Very good. 170.28. Nothing is mentioned, you can use fencer. Von Mises theory can be used. So up to sticking radius calculations, minimum pressure, maximum pressure, sticking radius. Up to sticking radius, what type of friction will be there? Based on the sticking radius positive, negative, we can know that which will be provided. I think please remember this point. If Rs will be negative, only sliding. If Rs will be greater than R, sticking radius is greater than R, only sticking. Please remember, where theory questions are coming like this. Rs is greater than R, only sticking. Next up, Rs is positive value. Both sticking and sliding, both will be there. Both sticking and sliding will be there. From 0 to Rs, sticking, center sticking hota hai na, sticking will be there. From Rs to R, sliding will be there. Rs to R, sliding will be there. Sliding friction is exponential. Whereas sticking friction is linear. Sticking friction is linear, sliding friction is exponential. Sliding is exponential, sticking is linear. Please remember this point. Okay, na? So up to this, how to calculate the sticking radius, sticking length, what type of friction will be there? This type of questions we will expect in GATE examination. Okay, na? Right. Yeah. So this is a very good question, friends. Little bit lengthy, but it's a very good question. Very good question. This type of questions we can expect in GATE without any difficulty. Okay, na? A 20 mm diameter rod is reduced to 15 mm by drawing in a single pass. Given that semi-dangle coefficient of friction is, what is the maximum percentage reduction in area? Take, please look at the board, all of you. Take K equal to 500 megapascals, N equal to 0.3. Flow stress relation is given for the material. So we need to calculate maximum percentage of reduction corrected to nearest integer, he said. So flow stress will be equal to K epsilon to the power N. So he has mentioned that K 500 epsilon to the power 0.3 is a flow stress. And it is a drawing operation where strain hardening will be there, and we have to calculate what average stress has to be calculated. So it is a drawing, please think of where sigma average will be equal to sigma naught, sigma average friends, yeah, sigma average we have to calculate will be equal to k epsilon to the power n by n plus 1 we have to consider. So this we have to consider. Flow stress will be also considered. And where maximum reduction hota hai, maximum reduction is possible. Look at closely, maximum possible reduction kahan pe hota hai? When, what is the condition for maximum possible reduction? If drawing stress will be equal to flow stress, not average stress. Drawing stress will be equal to flow stress, maximum possible reduction hota hai. Maximum possible reduction is coming when drawing stress will be equal to flow stress. Drawing stress will be equal to flow stress, maximum possible reduction hota hai. That we have to find out. Okay, na? So first we need to find out the true strain, friends. Yeah, true strain is ln A naught by AF. So this will be equal to ln diameter as given, na? Right? Sorry, 20 by 15 whole square. Diameter means it is whole square. So what is the value? True strain is how much, you can tell me? True strain is how much, you can tell me? True strain is how much? 0.75. Correct? Please check it. 0.75. So you can find out here, friends, sigma average is how much? K 500 into 0.575 whole power 0.3 by 0.3 plus 1. So what is the sigma average? Average stress kitna hota hai? Average stress is how much? Sigma average is how much? 325.78. Please check it. This is average stress. Flow stress, maximum stress at the end of this forming operation, maximum stress is flow stress, k epsilon to the power n. K is 500 into right 0.575 to the power 0.3. So what is the flow stress? Flow stress is how much? Flow stress will be 423.56. Okay. Now this true stress we have calculated, friends. Now I will consider drawing formula. Drawing stress equal to sigma average 1 plus B by B into 1 minus AF by A naught whole power B. There is no back tension here. So nothing is mentioned means there is no back tension. Back tension you can discard. So here I will find, friends, this AF minimum I can find out. So maximum possible reduction means final diameter, final area is both small hai na. Final AF minimum, if reduction is, I am keech, you will drawing this rod so that diameter should be minimum. So percentage of reduction increase hota hai. So final area should be minimum. When maximum possible reduction is there, final area should be minimum. Final area should be minimum. Okay? This one. So what is the drawing stress here? See, drawing stress equal to flow stress here. Drawing stress equal to flow stress. Don't cancel here, because without strain hardening means you can say flow stress, yield strength, both will be same, that we are cancelling. Here strain hardening is there. That's why average stress is different, flow stress will be different. Please remember this one. That's why I have taken this problem. So drawing stress is equal to flow stress at maximum possible reduction, that is 423.56. Very good, very good. Mean stress is 325. Very good, very good. Correct. That is, what is that 400? Somebody is saying 400 kya hai ji? Previous wala? Okay. 420. Sigma average is how much? 325.78 into, so beta, sorry, B equal to mu cot alpha na. Please calculate B equal to mu cot alpha. Oh, sorry. Kahan gaya? Yeah. B B equal to mu cot alpha. Please tell me what is B. B equal to constant mu cot alpha. Cot alpha. Mu is 0.25. Cot alpha is cot. What is the, please think of degrees. What is the semi-diagonal? How much he has given? 5 degrees. So what is this value? Please tell me. Cot. 1 minute. Cot 5 degrees. $1.714. Yes, very good. 1.714. Oh, I'm writing here. Oh God. Yeah. So B equal to mu cot alpha, friends. B equal to mu cot alpha. So 1.714 our friend is given, very good. So 1 plus 1.714 by 1.714 into 1 minus AF minimum. So this you can find out directly, AF minimum by A naught whole power B. B is 1.714. 1.714. So from here you have to calculate AF minimum by A naught. Yeah. Please think of AF minimum by A naught is 0.36. 0.36 you are considering. So percentage reduction. Percentage reduction is 1 minus AF minimum by A naught. 1 minus see around you are getting 63%. 63% आता है ना? Yeah, very good. AF meant 0.3667, correct? It is 63%. So he is asking corrected to nearest integer. Corrected to nearest integer. Integer means we can say 63%. 63% we can consider. Yes, very good. Very good. 63% we are considering, friends. 63%. Very good. Yeah. Please look at this question. This is a little bit lengthy, but this type of questions we can expect where flow stress, average stress here. Average stress is this one. Flow stress equal to drying stress. When maximum reduction will be there. Maximum reduction will be there, we have to consider. Yeah, please think of this question. Please give the answer. Mass production of seamless tubes are produced by which of the following process? Mass production of seamless tube. Continuously we have to produce more length of the hollow tubes. More length of the hollow tubes can be produced by which technique? Very good. Extrusion. Friends, by providing a mandrel. In a die, if you provide a mandrel, or for the plunger itself, you can add a mandrel. Over the mandrel, if the metal is moving equal to diameter of the mandrel, hollow tubes can be produced in mass production by using the technique called what? Extrusion. Mass production. Small tubes can be produced by roll piercing also, where length is less. Roll piercing we have discussed now, that can be also used to produce the tubes, but more length. Mass production means we can go for extrusion. Extrusion में use कर सकता है. ठीक है? Right. Very good. Right. Now this question has given friends last year. It is more confusing for you. I think to clarify that I have taken this question. This question has given last year GATE examination. To clarify your doubt, I am giving this particular question. It will be not repeated, but the questions are given like this. Okay, na? Last year question I saw friends here. So circular disc of 20 mm diameter is to be produced by blanking operation. So it is a blanking operation. It is a blanking operation, clearly given, blanking operation. Sheet thickness is given 2 mm. Sheet thickness is good 2 mm, but shear strength is not given. Which metal is not given? Shear strength is not given. And here he has not given clearance here. Just he has given allowance. Please read the question carefully. Allowance he has given. And allowance also, please observe. Die allowance or punch allowance he has not given. Die allowance or punch allowance is not given. Okay, please observe here. If die allowance or punch allowance is given, so we can say diameter equal to, please think of friends here, and we can think of if punch die allowance is given, punch or die allowance is given. Let us say this is which operation, my dear friends here? It is a blanking operation. Blanking operation, die size is fixed. Okay, and please right. Let us say he is asking punch size. Punch size will be equal to, you can say, D minus 2C plus 2C plus. Now die allowance we are considering. Die allowance we are adding. Die allowance or punch allowance can be added here. Die allowance or punch allowance he has to specify. He has given allowance. It is not given punch allowance, die allowance is not given. That's the first point. Second point is, he has not given clearance, radial clearance is not given. So if you want to find friends, when allowance is given, clearance C, radial clearance C will be equal to allowance multiplied by thickness. Allowance multiplied by thickness. It is not die or punch allowance, it is simply allowance. It is simply allowance. This allowance multiplied by thickness will give what? Clearance. What is allowance? 0.04 multiplied by 2. How much you are getting friends? 0.08. So 2C, diameter clearance is what? 2C means 0.16 will be the 2C. 0.16 is 2C we can consider. 2C is 0.16. 0.16 is the 2C. Are you getting me? 0.16 is equal to 2C. 2C equal to 0.16. 2C equal to 0.16. Clearance. Now if you want to find friends, punch size will be equal to D minus 2C. Here there is no need to add the allowance. Here we have to add die or punch allowance only here. 2C plus some allowance, that is as a factor of safety. If the punch allowance or die allowance is given, it has to be added. Punch or die allowance has to be added for the clearance. But he is mentioned allowance. By using the allowance, I am finding the clearance, because clearance is not given. Clearance is not given. So it is 20 minus 0.16. How much it is, friends? 18.84 mm. Please check this one. 18.84 mm. When the die allowance or punch allowance is given, we have to add like this. Die allowance or punch allowance is given, simply it is added to the clearance. As a factor of safety, it can be added to the clearance. But here, he has simply mentioned allowance. Please check the answer. Question. Simply mention the allowance. So allowance means It is not punch or die allowance, simply allowance during the cutting operation. To find out the radial clearance, that allowance has to be multiplied with thickness. That allowance has to be multiplied by thickness. Will give what? Radial clearance, diameter clearance. Then we can find out. 19 point, correct. 19.84, correct, sorry, 19.84. Yeah, very good. 19.84, correct na? 19.84 mm, 19.84 mm we can consider. Okay, whenever clearance is given, you can think like this, okay, allowance clearance like this, right. This please think of. A sheet of 100 mm length is cut by a blade of length 200 mm. Length of the blade is 200 mm. Like blade length is 200 mm. Blade length of the blade is 200 mm. But it is cutting how much? The sheet length of the cut will be equal to 100 mm only. Please observe this point, friends. So whatever the length of the blade, but I am cutting, the length of the sheet will be 100 mm only. Length of the cut is 100 mm. So in case of blade, if you consider cutting force, my dear friends, here will be equal to perimeter multiplied by T multiplied by tau s. Okay. So here perimeter means what? Length of cut T tau s. Please observe. If it is a blade, perimeters means it is a length of cut. L is length of cut. By using the blade, how much sheet you are cutting? Even scissors also. Using scissors I am cutting. Perimeter means the length of the cut. Capital P is what? Perimeter. Perimeter of the cut is length of cut here. So length of cut is 100 into thickness of the sheet is how much? 1 mm into shear strength is 240 megapascals. What is the cutting force? What is the cutting force? (24 kilonewtons). 24 kilonewtons. Clear? Yes. Perimeter means length of cut. Blades length of cut. Please, we have to consider here. Yeah, this question please look at, friends. With respect to this question also, some of them are having doubt. That's why I have considered. Determine the percentage reduction in punching force. Determine the percentage reduction in punching force for punching a hole of 40 mm diameter in a 2 mm thick metal strip. If 1 mm shear is provided on the punch, 1 mm shear is provided on the punch, 2 mm thick we can consider. Shear strength for the material is 400 Newton per mm square and assume 50% of penetration. So whenever the shear problem is given, shear is provided on the punch is given, right? Shear is provided, we have to check. S is greater than PT, we have considered two conditions. S is greater than PT or S is less than PT we can consider. Or less than or equal to we can consider. S is greater than PT. What is the condition, friends, here? Fs maximum into PT will be equal to Fs into, right? What we can consider, friends, here? Fs into S. Fs into S only here. Correct? Fs into S only we will consider. S is less than or P2 here. Fs maximum PT will be equal to Fs into S plus PT. S plus PT. S plus PT we can consider. So whether it is greater than or PT, S is greater than PT or less than or equal to PT we have to consider. So what is S here friends? S is 1 mm. PT is 0.5 into 0.5% penetration, thickness is 2 mm, it will be equal to 1. So S is 1, so S is equal to PT, that is equal to 1 mm. So which formula we have to use friends here? Can I use S is equal to PT? It is not greater than. If it is a greater than, I will use this formula, my dear. First formula, S is greater than PT. Force versus displacement diagram is trapezoidal. I can use this particular formula. Otherwise, I can use this particular formula. So if I am using Fs maximum, without shear, this is force is more. Fs into S plus PT. Okay, please think of concept friends here. Fs maximum, I will keep it as it is only. PT is just now we are discussing 0.5 into 2 will be equal to Fs. We need to find out here. Yes, S is what? 1 mm. PT 0.5 into 2. So here Fs will be equal to Fs maximum by 2. Fs equal to Fs maximum by 2. कितना परसेंट रिडक्शन हो गया? कटिंग फोर्स परसेंटेज रिडक्शन in the cutting force, percentage reduction in cutting force will be 50%. Percentage of reduction in cutting force will be 50%, 50. This concept is clear? अरे बोलो ना थोड़ा, बोलो. Can you please look at it? Is correct? 50% reduction है ना? Please check the condition. S is greater than PT or S is equal to or less than PT. Less than or equal to means I can use this one. Greater than PT means we can use this concept. Okay. This you can think of it here. It's a bending case, friends. Bending case, bend allowance we are discussing now. Bend allowance next, bend radius, right? Strain developed at the outside fibers equal to 1 by 2R by T plus 1. This is a formula we are using now. Bending formula. Bending formula ऐसा होता है ना? The minimum radius to which a sheet of thickness 4 mm can be bent if the percentage reduction area of the metal in tensile testing is 30%. So 30% reduction he has given. 30% reduction in area is given. So from that we can find the strain. If you find the strain here, from I will find out the radius here. So percentage of reduction is given. Area reduction is given. So percentage reduction in area. A0 minus AF by A0. So this is 0.4. 1 minus AF by A0. So AF by A0 will be equal to 0.6. So ln, true strain na, ln A0 by AF. So this is ln 1 by 0.6. ln 1 by 0.6 means how much? Please tell me. ln is 0.5 anna. true strain will be equal to 0.51. Correct? Yeah. Now if you know 0.1 friends, here this is 0.51 1 by 2 R. R we have to find out. Thickness is 4 mm plus 1. From here you need to find out what should be the R value. Radius is how much? Okay, Vaibhav. R equal to how much? Radius is how much? Yeah. 1 mm? No. Radius of the curvature is how much? .915. Okay. Okay, that will be 1.92. 1.92. Okay, good. 1.92. Right. Now this, please think of friends, two questions are there. Last two questions we will close it. This is the process and what type of stress will be there. Stress condition, please observe here. Coining and embossing. Coining is a cold forging operation. Compressive stress will be there in coining. Punching, it is a shear. Punching, shearing operation. Stretch forming, it is a tension. Deep drawing, tension and compression. So 1, you can think of C, 2, D, 3, B, 4, A. This we can consider. This option we can say this is regarding. This question is clear. Now the process and what is that we can say? Stress developed. Process and stress developed is what? Process and stress developed. This question is clear. Yeah. Yeah, this defect you can observe friends. With respect to defect, one question I have given. Which of the following defects are correctly matched with the corresponding process? Corresponding process, you can think of which defect is correctly matched. Misrun is a casting, na? It's a pouring metal defect. Pouring metal defect. Misrun is a casting defect. Correct. Pipe defect or tailpipe defect, it is an extrusion due to improper cleaning of the oxide layers. All the oxide layers will be reaching to the center of this pipe, na? Extrusion. Correct. Orange peel effect is a deep drawing. Santra, coarse grain structure is there in the sheet material. At punch corner, rough surface is producing, that is called orange peel effect. Wavy edges, rolling operation, wavy edges. Due to roll bending, edges will break. Wavy edges means, it will be happening friends, like this. The sheet metal which is producing is having edges or breaking. It's called wavy edges. So all are correct friends here. All are correctly matched here. All are correctly matched here. Very good. All are correctly matched here. Okay now? One question you can look at with respect to powder metal. Last question for today. Last question for today. Following are the process used to form powder metallurgy to shape the object. To shape the object. Which type of processes can be used to shape this object? Sintering, blending, cold isostatic pressing and impregnation. Process used to form the powder metallurgy to shape the object, to get the object. Powder metallurgy, you can observe all these operations. Sintering can be used, blending can be used, cold isostatic compaction, impregnation, all this can be used. All right. Impregnation or infiltration is also there, na? This one. If you see the sequence, friends, sometimes if the question is given, what is the sequence? What is the sequence as given in case of one? So first you can say metal powders production is there. Second one is blending. First process is blending. After blending, we will go for compaction, isostatic compaction, BC. Then we can go for sintering, A. Then followed by D, impregnation. Impregnation, infiltration and impregnation. Impregnation, lubricants can be allowed to sintered product to increase the density of the object. BCAD, yes, very good. Sequence means BCAD. So that's all for today. Friends, I hope I have given some questions to you. So new questions, at least you have practiced some of them. So you are good at numericals. You are doing good at numericals, there is no doubt. But theory also you have to focus, because 20 to 30% theory questions are coming. 30, you can say 70 to 80% we are expecting numericals. So if you want to get better rank, theory also you have to revise. So please revise the notes once again, or if you have prepared the short notes, anything is there. I have given already short notes also in the notes provided to you. Please revise these notes and please try to attempt theory questions also without any mistake, so that you will get better rank in the GATE examination. Wish you all the best, my dear friends. Do well. Don't please in between. Some of them are leaving in between, right? Because exam is on February 2nd. So in between, please prepare well, be cool, prepare well and do well in your GATE examination. Success is yours. Okay, wish you all the best. Thank you very much. And if you have any queries, I think already my number is with you. If not, you can see my WhatsApp number. You can please check this. Yeah. Metal cutting हो गया ना? Metal cutting already Gunjan sir has taken na. Metal cutting हो गया ना? So production, both production 1, production 2, both production is over. Gunjan sir has taken na. Yeah. Thank you very much, my dear friends. Thank you very much, my dear friends. Wish you all the best. Do well.